Good morning, Mukesh sir. Good morning, dear participants.
Good morning, ma'am.
Okay. I am profoundly delighted to take an opportunity to introduce our guest, Dr. Mukesh Kumar Garu, Assistant Professor, Department of Computer Science and Engineering, National Institute of Technology, Patna. Dr. Mukesh Kumar Garu has done his BTech from Cochin University of Science and Technology, MTech and PhD from National Institute of Technology, Rourkela. His research interests include big data, machine learning, deep learning, software engineering, and bioinformatics. He has published 9 journal articles in reputed journals so far and presented papers in 13 conferences so far. Presently, he is working on a project entitled Healthcare Data Lake, an intelligent search and analytics platform for improving healthcare plans and treatments, funded by NIT Patna. Now, on behalf of STTP team, I request Dr. Mukesh Kumar Garu to take over the session and cast the light of his knowledge upon us. Mukesh Garu, please continue the session, sir.
Thank you, ma'am. Thank you. Thank you to all, and good morning to all participants. So, I am Mukesh Kumar, and I am going to present a lecture on the topic of big data analytics in cloud computing. Means what is the application of big data in cloud computing and how we use the services of cloud computing uh, to incorporate the big data. Okay. So let me share the screen. Ma'am, can I share the screen?
Yes, sir. Yes, sir. Sure, sir. It's me, Naveen, sir. Good morning.
Yeah. Good morning. Good morning, Naveen.
I have given you a presenter.
Okay. Okay. So is it visible now?
Yes, sir. Yes, sir.
Okay.
Visible.
Fine. Thank you. So before going to big data, our main aim is to how we use the services of cloud computing to incorporate the big data. So as we know that cloud computing is nothing but it provides the services or it provides the resources to user over the internet. Okay, and this refers to the processing of anything including big data analytics on the cloud. Okay, the cloud is just a set of high powered servers from one of the many providers, and we know that this is the era of big data where data is the size of data is enormous in size, and day by day it increasing exponentially. Okay, so it is the set of large set of data collected, and we know that while cloud computing refers to the mechanism that remotely takes this data in and performs any operation specified on that data. Okay, actually these both terms are very different, but these two terms are totally complementary to each other. Without these both, no one is complete. Okay, because to do the big data analytics we need the services of cloud as a software or as a platform or as a infrastructure. Okay, and when we have lots of data, then to store or to analyze the things we need the servers or high-end machine, and we know that this is the era of deep learning or artificial intelligence, and we need a large computation power like GPU and much more, means high power machines. So we cannot buy all the things, so we need to take a lease from the cloud, or for the service purpose we can take for a small amount of time if we need. Okay, so here we these two both terms come, big data and cloud computing, And so our main focus will be on big data, not on the cloud, because we know that we have to use the services of cloud. But how big data platform going to use the services of cloud? Here we will discuss the architecture of big data and what are the platforms where we can analyze these data sets. Okay, and so Hadoop is the major platform, and we discuss the component of Hadoop like HDFS, Mapreduce, little bit of a Spark, and how we write our own algorithm so that we can do all these things. Okay, so here we will discuss some basics of big data. What is data and what is big data? We will go one by one. Okay, so data is nothing but it is a quantity, characters or symbols on which operations are performed by the computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical or mechanical recording media. Okay, actually data is the smallest quantity of information we can say. But what is big data? Actually, big data is a buzzword that comes from the computational science, and it is used to describe the scenario where the volume and variety of data types overwhelm the existing tool to store and process it. And this definition is given by Hortonworks. This is the major company of big data analytics that provides all the services and its ecosystem to do all the things on a cluster. Okay, and MIT Technology Review has given a definition like it is a term describing the storage and analysis of large and complex data set using a series of techniques including but not limited to NoSQL, MapReduce, and machine learning. Okay, there are various examples of big data like NYSC generates about 1 TB of new trade data per day. And on social media we see how our statistics of data is going on day by day. We are sharing our pictures, videos, so at least 500 plus terabytes of new data generated and ingested on the database of social media like Facebook, Twitter, Instagram. Okay, and a single jet engine can generate 10 plus terabytes of data in 30 minutes of lifetime. So to analyze this kind of data, we need a platform or machine so that we can do in a single go, or means within a specified time limit. We cannot wait years to years to analyze or months to do these things. Okay, in retail industry, supply chain management, medical industry, transportation industry, information technology industry, and there are many areas where we have big data and we need to do the analytics in a very efficient manner. Okay, so Hadoop is a platform to do these things. Okay, so what Hadoop can do? So Hadoop can be used as a ATL. ATL represents for extract, transform, and load, and it is a common data processing operation. So these are just the basics of things. It can be used as exploration engine because that we don't know about the raw data. We just put on the Hadoop cluster and we can explore using the exploration engine. Okay. Hadoop can be used as a data archive because it has enormous amount of storage space, and in runtime we can add number of nodes in a cluster. So based on our requirement, we can remove or add any number of nodes in the cluster, and to store or data archive purpose we can use the Hadoop also. So it works on various kind of data like structured, unstructured, and semi-structured. So what is a structured data set? Any question? Any doubt up to here? Okay, no problem. So structured data resides in a fixed field within a record or file. We can say that it depends on creating the data model called a schema. The schema defines the type of data that will be recorded and how the data will be stored, accessed, and processed. This includes defining the fields of data to be stored along with the type of data in each field. And data type may be string, integer, floating point numbers, dates, and others. So advantage of structured data is it can be easily entered, stored, queried, or analyzed, and it can be easily managed by the SQL programming language. Okay. So next one is semi-structured. So semi-structured is nothing but it contains the tag or other markers, and they just separate semantic having an enforced hierarchy of records and field within the data. So example include like HTML, XML, JSON object. Okay, it is also called self-describing data. And next one is unstructured data. So it doesn't have any proper format or proper fixed field or records. There is no data model. Okay, so nowadays we see that 80 to 90% of data in any enterprise is unstructured. So Hadoop primary contribution is to store unstructured data and find the useful information or extract the useful information from them. Okay.
So, sorry, sir.
So what?
Mukesh, sorry, it's me, Naveen.
Yes. Yeah.
Can you explain, sir, what is the difference between a structured data and unstructured data with respect to big data?
Structured data, we can say it is a data that has defined schema, means where we have to put the first row, means first field, means first cell, we can say. Suppose we are entering the data in the table. So table having defined schema and all the data types has been defined there. So only we have to put data in that form. But in unstructured data, we don't have any data model or any schema. We just like text or books kind of thing, means okay, where there is no schema, we can put anywhere any type of data like tables, images, text in one proper page, one page we can say. Okay, so these are unstructured. Is it clear?
Clear, sir, clear, sir.
Okay, so what makes data big data? So in 2001, industry analyst Doug Lane described big data using the three V's: volume, velocity, and variety. So if data having any of these properties, then we can say that data is big. Okay, or we can also say that if data is not capable, means if our machine is not capable of doing the processing for the particular data, then we can say that for this data, for this machine, the data is big data. Okay, so this is the relative term. Big data is nothing but a relative term where we can uh, relatively say that okay, for this machine we cannot analyze our data, so we can say this is big. Or if any of these properties is satisfied, then we can say that the data is comes under the category of big data. Like volume means the amount of data being generated in terms of gigabytes, terabyte, or petabytes. Okay, velocity means the rate at which new data is generated, like megabyte per second, gigabyte per second, means like real-time data, means how we are generating the data and how we are going to process this data. We cannot store or do the analytics and give the result after 1 day or 2 day, like Twitter data, or like we can say traffic data we are analyzing, means where there is a traffic in current time, or what is the main reason, what is the cause. So we cannot store that data for a day and give the result tomorrow. Okay, so we need a infrastructure or platform so that we can give result at a time, during that time, means what is going on real time. Okay, so that's comes under this type of data. So here data is not in big volume, but the rate at which we are getting the data in the cloud or any machine, we need to do the processing. Okay, so that's also comes under, since data is not big here, but the velocity is very high and we need to give the results in a very efficient manner, so that comes under the big data also. Next one is variety. Variety includes structured, semi-structured, and unstructured, means different kinds of data we are going to deal with. So big data is a high volume velocity, and variety information assets that demands cost-effective, innovative forms of information processing for enhanced insight and decision making. And to deal with big data, we have a platform called Hadoop that provides a cost-effective, innovative form of information processing used to enhance business insight and decision making. Okay, so what is Hadoop? So Hadoop is an open source framework for distributed storage and distributed processing for very large data set on computer cluster. So Hadoop began as a project to implement Google Mapreduce programming model and has been synonymous with a rich ecosystem related technology like Apache Pig, Hive, Spark, AWS, and others. And it has been adopted by companies like Facebook, Yahoo, Adobe, Cisco, eBay, Netflix, and many more. Okay. So it has major components like HDFS, MapReduce, Yarn, and Jupyter used to resource management. So little bit we will see here how Hadoop works. Okay. So let me switch to. So nowadays Hadoop having 3.x version. Okay, so before going to this, we have initially it was 1.x and then it comes 2.x and then currently it's working on 3.x. So there are various changes over it, like how storage, fault tolerant, there are many things. So here we will discuss 1.x first and then we will go the extension of 1.x, how they are performing on Hadoop 3.x. Okay, so in Hadoop 1.x, the major component of Hadoop is nothing but HDFS and Mapreduce. Okay. So first we will discuss here HDFS. HDFS is nothing but the full form you can say Hadoop distributed file system, and it is a specially designed file system. Okay, with for storing the large amount of data set with a cluster of commodity hardware. Okay, with streaming access pattern. Okay. Commodity hardware is nothing but cheap hardware. Okay, so we can make our own cluster, or with very small machines we can make the clusters to store the data in a distributed manner. And streaming access pattern means read once, write once, and read many more times. Okay, write once and read any number of times. So on Hadoop or HDFS, we can store the data and we can do any kind of things, but we cannot update that data. Okay, at the same time. But suppose we have stored this data, at the same time we can open the Excel, open the means Pig we are performing, HBase we are performing, or any analytics like Spark analytics we are doing. Okay, so any kind of things we can do on this data at a time. Okay, so it will not lock or unlock the kinds of things. So traditional database system or traditional system on what we are using on the machine, they have locked the things only at a time. Only we can do one thing, but in Hadoop we can do parallelly many things. Okay, so what is the major difference means this normal file system like NTFS or HDFS? Suppose we are going to write the data and we know the in memory, suppose this is the memory location 500 GB. Okay, and these are the sectors. So in normal machine we can write the data as a size of 4 KB or 2 KB at a time. Okay, so suppose at this block we can write the data in a very small size, but in HDFS the default size 128 MB. Okay, or manually we can also set based on our requirement like 64 MB or any size we can set there. Means at a time 128 MB of data we can write on the memory in HDFS. Okay, but in normal file system we can only store 4 KB of data, and if suppose we have a data having 3 KB, so the rest amount of data will be wasted and it creates the hole in normal system. But in Hadoop, suppose our data set having 40 MB, so the rest memory space will not be wasted, it will be used for the another block. Okay, so it stores the data in the form of blocks, and block size will be of 128 MB by default. Okay, so first it splits the data and then stores in this way. Okay, so suppose we have a cluster of node 1. Okay, suppose this is the master node and these are the slab node. Okay, and client want to write some data on the cluster. So Hadoop having means SDFS having 5 major components, or we can say that these are the daemons like name node, secondary name node, okay, job tracker, data node, and task tracker.
Participants, it's me, Naveen. Please keep patience. I think there is some issue from the speaker side. Okay. We'll wait for a couple of minutes.
Sorry, sir. Actually, I lost my connection. So actually, I also didn't. Naveen ji, hello.
Sir.
So when I lost the connection, can you please tell me?
Sir, I think sir, last 5 minutes, sir, before. But
This Mapreduce. Let me share the screen first.
Okay. Okay.
Okay, so Mapreduce. So can we start from here? SDFS, working of SDFS.
Sir, you were in that position where you were discussing about components of SDFS, name node, secondary node.
Okay, fine. Okay. So any doubt up to here? So participants, please.
I request all participants, if you would have any doubt or anything, any query, please you can ask to sir, and or you can use, you can send your response by writing down in the chat box too.
Yes, that will be easy for us also, because we are losing the connection and we don't know what we are going to do that. So I think that will be good. Okay, so component of SDFS is we have 5 daemons, that is internal process or hidden process, we can say, that like name node, secondary name node, job tracker, data node, and task tracker. And internally these are the master daemons, and these are the slab daemons. And master daemons can talk to each other, and slab daemons can also talk to each other. Like data node can talk to task tracker, and task tracker can talk to data node, and job tracker can talk to name node, and name node can talk to job tracker also. And that master daemons and slab daemons means name node can talk to data node, and data node can also talk to name node. Task tracker can talk to job tracker, and job tracker can talk to task tracker. Okay. So these are the services that we are going to use to read and write the things data on the cluster, and to process the data set we use these services, job tracker and task tracker. So for storage purpose, name node and data node will come into the account, and for processing the data, job tracker and task tracker. Okay, so suppose this is the cluster of 8 nodes, where this is the name node, means master nodes, and these are the slab nodes, we can say. And this architecture works on the master slab architecture. Okay, So each slab nodes having data node and task tracker, and each master node having name node and job tracker. Okay, and suppose client want to write something. Means suppose we want to store. Suppose we have a 200 MB data set. Suppose the file name is abc.txt. Okay, and client want to store this data on this cluster. Okay, so it will interact with the name node directly. Okay, so and name node having all the details of data means slab nodes. So they are connected with the internet or local connection we can also. Okay, and each data node like slab node will send the block reports and the metadata. Okay, so master node having that metadata of all these things. So it will store means data node, the reports of data node, all the things. So all the information of data node, everything will be stored on the master node. Okay, so suppose client wants to interact with the master node. So master node know the details of all the slab node, and it send the detail. Okay, this one is suppose number 1, number 2, and number 3. Okay, so it will send acknowledgement to the client. So okay, client, go to name data node 1 means 2 and 3 and store your data. Okay, so now client will directly interact with this, and it will say to store the data set. Okay, so the data will be split into the blocks. So suppose our block size is 64 MB, then we have first block will be of how much? 64 MB, 64 MB, 64 MB, and 8 MB. Okay, so suppose this is the a b dot t. The part of abc is a b. Okay, so now it will suppose the client want to store a.txt, so it will return back 1 to 3 node number 1 and node number 2 and node number 3. You go directly and store there all the data set. Okay, so now a.txt will go to the data node 1 and it will be written here, and the fault tolerant purpose it will interact with the other node and right there. Means suppose we want to store 64 MB of data, then we need 2 more copies. If any failure occurs, it will be replicated from there. Okay, so for to store the 2 MB data set, we need 600 MB total. So this is for fault tolerant purpose. But in Hadoop 2.x or 3.x, we have a concept called erasure encoding, where we need only means extra 100%, means only 300 MB data we need. Okay, but in the old system we need 600 MB of data set. Okay, so it will send to here. Okay, after writing the data, it will send acknowledgement to the name node 2 and name node 1, and it will send to the client also by saying that we have successfully written the this data. And it also send heartbeat and block reports to name node that we have done. And when we the name node will receive the block reports, all the things, it will update the metadata also here. So a.txt will be written to name node 1, name node 2, means data node 1, data node 2, and data node 3. b.txt will be written to 2, 3, and 5. c.txt written to 3, 5, and 6, like that. Okay, by taking care of all the things like rack aware, and there are many things. So in this way, client write the data on the HDFS. In the similar way, it requests for reading pipeline. It requests to the name node. Name node to give the details of all the data, means where it is resides on which node, and data means data node client directly interact with that data node and receive back that data. Okay, so this is the read and write pipeline of Hadoop SDFS. Next one is Mapreduce. So here comes next services, job tracker and task tracker. Okay, so job tracker, task tracker. So here, suppose we want to perform a task called word count example. Okay, so that suppose we have written the code in Java or Python, any language we can write, any scripting language you can use here. Like suppose we have written word count.py Python. Okay, so client will submit the job tracker, and job tracker will interact with the task tracker. First, it will interact with the name node, and name node give the services all the details to job tracker, means here data will be resides. Okay, and it will interact with task tracker. So here movement of code is going on, not the data. So in network, only 2 KB of, suppose the size of this data, this code is only 2 KB and data size of 200 MB. So here data is reside on the local lab nodes. Okay, and code is moving in the network. So you can imagine the network overhead, means we are not going to transfer data over the network, we are only transferring the code. Okay, that's why it is fast, very fast, because we are not moving the data in the network. The 2 KB of data will move into the network and go to the different task tracker. Okay, and after receiving the task tracker interact with the data node. The task tracker, we have this code and you have this data, perform this task on that. Okay, so for particular data, here suppose we have a.txt, this code will be run. Okay, and this process is called map. Okay, so here also map, this is also map, this is also map. Okay, and it will give the result, each node will give the result, that is called intermediate results, that is given by the map. Okay, and after doing the intermediate results, after collecting all the intermediate results, doing the shuffling and sorting, this is the task of reducer, I think, reducer, and then reducer comes into the picture, and by aggregating all the things, it will give the final result on a particular node, and then it will send, master node send that say that hey client, you go to this number of this node and your result is there, and result will be stored in the file format. One file is success, that's only message that the job is successfully completed, log, and then part 0000. Okay, so in this file result is stored. Okay, so map is created based on our data splits, means how many number of data splits we have, that many numbers we have mappers. Okay, and reducer by default we have one, but this is manually we can put any number of reducer, 2 3 4 5. Okay, so the number of reducer decides the number of output files. Suppose reducer is 2, then we have part 1 and part 2. Okay, this will be 0 and this will be 0001. Okay, so 2 file will be generated. If reducer is 3, then 3 files will be generated. Okay, like that. But mapper decides the number of, means data splits decide the number of mapper data splits. So we can say that what is the data block and data splits, what is the difference between both. Okay, because we are dividing a data based on the block of 64 MB, but based on the data splits, we are going to the system will generate the number of mappers. Okay, so anybody, can you please describe the difference between data split and data block? So Naveen, any idea? Hello, am I audible?
Audible, sir. Audible, sir.
Okay, so data blocks
Sir,
versus data split.
sir,
So,
are you asking a question to me, sir?
no, just I want to means
Okay.
confirm that I am audible
Yes,
or
sir.
not. Okay.
Okay.
So
Okay.
actually, data split is nothing but a logical
Ah,
space, logical boundary of data, and this is the physical things. Okay, this is only the storage, and this is the logical partition of the data. And suppose we have records. Okay, suppose this is the data block. This is the complete data. Okay, of 64 MB. And in this block, we have record 1, record 2, and record 3 or 4. Record 1, record 2, record 3, record 4, record 5. Okay, because Hadoop means Mapreduce reads data in the form of records. Okay, line by line it will read. Okay, we'll see later. Okay, suppose here is the major point. So at a time, one record will be read by the mapper or record writer, but here we see this is the boundary for each block, the first block, but here record is only, it will go to the next block. So logically, what will going to happen, this
sorry,
record
sir.
will be combined. Yes,
Sir, can a split size be less than block size?
split size less than block size, yes, possible.
Means in general phenomena, what we observe that the size of a block as well as the size of a split are equal. So
Yes. Okay, so take this scenario. Suppose our record size will be increased means suppose our record size go to this block also, means this part will go to the next block. Okay, so when we are going to perform the mapper, this record will be combined at once. So this size will combine, either come to this size, or either this size either go to this side. Anything can happen, na?
okay. Understood.
Block size is 2, but split size, suppose we have splitted these things, split size is also 2, no problem. But this record will go to either this side or this side. So this side, if we observe, so our split size is not 64 MB here, only a split size is this one. For this split, we will create one mapper, and for this split, we will create one mapper. Okay.
Okay, sir. Understood, sir.
So this is the logical thing, means only we need to group the records so that our record will be complete. Okay, so that we can do the processing. And suppose we are going to perform roll number is 1101, and this is name. Suppose name is Ram, is a good boy, or anything, any information we are going, marks, grade, suppose in subject 1 A, B, C, D, E, like that. Okay, so we cannot break this one, because here we are going to lose the information. Okay, so what will going to happen, logically it will combine into single record. So if this part will reside on different blocks, but during the split it will combine once, so that this record will be complete. Okay, and it will be independent to different records, so that we can do all the processing here. So this is the logic. So this is the major difference between splits and block, and based on the splits, mapper will be created, not the based on the block. Okay, So suppose we want to process. So suppose we have 200 MB of data. Okay, and we have 4 splits: 64 MB, 64 MB, 64 MB, and 8 MB. So for each data splits, we have one mapper. So 4 mapper will be created for that particular example: mapper 1, mapper 2, mapper 3, mapper 4. First we have input splits. Okay, input split and input split, input split, input split. So suppose we have 4 input splits. Based on that, we have 4 mapper, and for each mapper we have record writer in between this. So the role of record writer is to read the records from the input splits, okay, in the form of offset and entire length. So there are various forms like text input format, key value input format, sequential file input format. Okay, so in this way, suppose by default it text input format we are considering. So what in this format, what we will do, it reads entire record at a time. Okay, so key will be offset and entire line will be the value. And we know that key means Mapreduce works on the key value pair. So in this way, it will read the records one by one from the input splits. This is record reader. And this record go to the map, and mapper will do based on our logic. Suppose we are doing word count. So based on that, it will splits the entire line into the tokens and give some value. Means based on our logic, we will do all the things. Okay. And suppose we have high, I am this, I am that. So based on that, it will tokenize and count all the things. So in a similar way, the record reader will do here, and the entire line will be processed. Okay, so these are the mappers. After getting the results, all the files, all the intermediate results will be collected and shuffle and sort. Next page is shuffle and sort. In that, what we will do, shuffle and sort, what we will do, it will group the key by value. Means it will group all the keys. Okay, because suppose we have file likes hi. What is your name? Hi. How your college, kind of thing. So here hi becoming 2 times. Okay, hi 1, hi 1. In this way, it will be tokenized. Okay, so in shuffle on sort fetch, what we will do, it will be combined, means hi, and it comes under like 1 and 1 in this way. Okay, so these keys will be grouped, and all these things will be done. And shuffling, sorting will be done based on the alphabetical order, and this is the main major role of reducer. And then this will be input for reducer, and reducer will do all the aggregation, means I becomes 2 times, I becomes 3 times, kind of thing. Okay, and this result will be written back to the cluster node. From there, client will read all the results. So this is the basics or basic fundamentals of working of Mapreduce and Hadoop HDFS. Okay. So any doubt?
No, sir. No, sir. Nice, sir.
Okay, so can we take some means? Do you have time?
Yes, sir. Yes, sir.
15 minutes we have, na? Okay.
Yes, sir. Yes, sir. 10:45, sir. Up to 10:45, sir. We have time.
Okay, okay. So these are the some all the details of HDFS and the things. So how these things will work: set up a pipeline, write pipeline. Mapreduce is a framework to process data in parallel across many machines. So Mapreduce has been the basis for Hadoop's data processing scalability. Mapreduce work by distributing the program code across the machine cluster. Okay, so all things we have discussed, I think. So this is the life cycle. So here you can see client submit the job and to resource manager. Okay. So one thing we have missed, I think. So in Hadoop 1.x, we have job tracker and task tracker, name node and data node. So in Hadoop 2.x and 3.x, we have segregated the services, like we have resource manager, node manager, containers, application master. Okay, so the key difference between pre 2.0 and post 2.0 is Mapreduce took care of its own resource allocation and job scheduling, as well as the actual computation. Earlier, it was the job of Mapreduce, like job tracker, to do the resource allocation and scheduling of job. But in newer version of Hadoop, like 2.x, it decouples all the scheduling from the computation with Yarn. So Yarn is the main operating system, you can say, of Hadoop that do all these things like scheduling of our task scheduling or resource negotiating kind of thing. Means how many resource we want. Okay. So Yarn having three things like resource manager, application master, and node master. So node master we can compare with earlier version, like node master is nothing but the task managers, and resource manager and application master. Resource manager is nothing but the job tracker. Okay, and application master is a negotiator between resource manager and resource manager to give the resources based on the application. So this is the major difference between 1.x and 2.x. Only difference is decoupling of resource management and the scheduling of job. Earlier it was combined and handled by job tracker, but nowadays everything will be separated, and based on our application we can request for resource. Okay, so in one machine we can have many applications running on. Okay, so here only we start the different containers, and based on that containers, in that container, suppose the size of container is 1 CPU we are going to allocate and 2 GB RAM. So for each container we have node manager, and node manager run on 1 CPU and 2 GB RAM. So suppose our machine having 8 CPUs, one machine having 8 CPUs and 16 GB of RAM. So here we can start 8 containers at a time. Okay, with resources of 1 CPU and 2 GB RAM. So 8 application we can run parallelly, or one task if we are going to run. So the complexity of the task reduced by 8, because we are starting 8 processes at a time. Means parallelly we are processing 8 jobs here. So in this way we are going to, means we can use the resources. Earlier it was not that. Only one machine, means one container is there, and all the resources is going to vanish in that only. But here we can start different with setting of different resources. So these are the details. So Spark, next is Spark. Spark is nothing but advanced version of Mapreduce, we can say. Where, so the merits of Mapreduce we can say was when we are going to implement the machine learning kinds of thing, where for loop is there or different variables we are going to use. So earlier it was not there. Means it was there, but we had to read the data many more times and write on the disk again and again. But in Spark, we have this type of concept, like we can create the temporary variables like accumulators, we can broadcast the variables, we can in-memory computation we can do using RDD, resilient distributed data set. Okay, and it works similar to Mapreduce, but it is advanced version of Mapreduce, where we can apply all the things like for loop and temporary variables. Okay, and this is the architecture, like a Spark context. First we create the Spark context. Okay, and this is the executors that runs on the worker node. So I think we will see some applications, like how we write the codes on Mapreduce or on a Spark, like simple things like t-test, Anova test, Wilkinson test, fragment test. Okay, so first we, or leave this one. Suppose we want to calculate the average of the things, means average of marks of each student. So how we will do? Any idea? Anybody? Suppose in our class we have 100 students. Okay, and each student having 5 subjects, and we have marks of 5 subjects. Okay, suppose 10, 15, 20, 25 and 30, and we need a result of means total marks. So how we will do? Any idea? Using Mapreduce. Student 1 S1, suppose S2 we have 11, 14, 35, 20, 25. Okay, so any idea? Okay, so first suppose we have 100 students. Suppose the file size is of 100 MB or 10 MB. Okay, suppose our block size is 1 MB. I have done the setting. Okay, so it will be splitted in the form of 1 MB file. So total 10 MB. So 10 splits will be there, means 10 blocks will be there. Okay, and in one block suppose S1 S2 is there. Okay, so this record will go to the mapper. So here we will generate key as a student and value as this. Okay, as a list. Okay, key is a student or unique ID, you can say. Na student name will be there, then it will be duplicated. So suppose this is the roll number. Roll number will be unique. Unique things we can assign there, so that there will be no duplication of keys, and it will go to the as a list. Okay, so in map thing we can simply do these things, means we can set as a key this one, and this is this as a list. And in reducer part, what we will do, we will add these things. Okay, all the list. For this key we will add 10 plus 15 plus 20 plus 25 plus 30. Okay, so this is very simple task, we can easily do using Mapreduce. Okay, in a similar way, suppose we want to do Anova, analysis of variance. So what we will do, suppose we have a data set of m cross n of dimension. So the things we know that first we calculate the variation between the groups, then we calculate the variation within the groups, and then we compute the degree of freedom, and finally f statistics, we calculate BMS divided by WMS. Okay, for each sample, we can say, for each sample, yes. So we will compute these things, and based on the f value, we say that what is our hypothesis and what confidence interval we are going to consider, and based on that we can either accept the hypothesis or reject the hypothesis. Okay, so suppose we are doing the feature selection using Anova in machine learning program. So what we will do, means we only select that features, and this is the classification problem. Suppose we are going to means divide either cat or dog, and we have 10 features, Means we have first we are doing feature selection. Means feature selection means we are selecting only those features that are capable to do the classification task. If any features that is not capable of doing this task, we will remove that. Okay. So our hypothesis is first we make the hypothesis that mean between these two groups is sufficient enough. The difference between means are sufficient enough that will do the classification. Okay. So we can say that our null hypothesis is mu and mu1, means this is the category of 0th class, this is the first class. So mean between these two is or x bar. Okay, and alternate hypothesis is what? 2. Okay, so first we calculate all the things if a statistic, and based on the confidence interval, suppose 99% confidence interval we are considering. So if our data comes under this curve, suppose this is the t-test. Okay, so if our hypothesis or p value comes under this region, it means that we have alternate hypothesis accepted, and in this region null hypothesis have been accepted. Okay, so only those features that comes under this one means this is totally different. It means that we are only considering the alternate hypothesis, means are different. So we will consider these features that comes under in this region. We will leave or remove these features from our data set and only consider these features, and based on these features we will do the next analysis. Okay, so these things we can easily do the using the Mapreduce. So what we will do, calculate the between means, then within mean, then calculate f value, and then for each means key value pair, f value and their corresponding p value we will emit from the mapper, and this value line number 7 go to the reducer part. Okay, and after that based on the p value, this is the threshold for confidence interval, means 99.9 we are considering here. So if p value is less than this, then we select that features, otherwise we will discard that features. Okay, and here we will emit the selected features. Is it clear? Any doubt here?
For me, it is clear, sir. Participants, if anyone has any doubt or any query, please feel free to ask to sir.
Yes, because this is the simple thing we can apply anywhere in our application. Okay, but how we will do using Mapreduce or using a Spark in parallelly? Suppose we have features of 10 millions, so we cannot do one by one 10 million times, and if we are doing that things using Mapreduce, we can easily do. Okay, so if you have any doubt or if you are doing research in this field, that will be very, I think, interesting area to do the things. So any doubt? No doubt. Okay. So if you write your code in this way, your code will run on the Hadoop and you can perform all these things. Okay, otherwise you will go one by one in sequential manner, and it will take lots of time. Okay, in similar way, Kruskal Bali we can also do, fragment test we can also do, Wilcoxon test also we can do. Okay, one example we will take from the machine learning. I think this is the logistic regression, the simplest one. Okay, I think KNN everyone knows, right? What is KNN? K nearest neighbor.
Participants, give your confirmation. about this. I request to all participants, please.
So how we will implement k nearest neighbor using Mapreduce or Spark? Okay, suppose we have a training set in machine learning. We all know we have some training test and testing data set and training data set. Okay, so this is training data set and suppose this is the test data set. Okay, and suppose we want to use KNN. So how KNN works? KNN finds the similarity between any existing data set. Okay, suppose these are the data set having 0 class and 1 class. Okay, so what it will do, and this is the test sample. We don't know the level of this test sample. We want to predict what is the level of this sample. So what it will do, it will go to the training set and try to compute the similarity between them, means or distance between them, means how close to these samples. Okay, so it will compute to all samples. Suppose this is 10, this is 5. So it will compute to each samples individually, and then suppose this is the D1, D2, D3 up to D10. Okay, and then what we will do, we will sort this distance, and based on the sorting, suppose D1, D5 and D7. Suppose k value is 3. Okay, k is 3 we are considering, and the nearest distance is D1, D5 and D7 we have, and D1 we know this is the positive class, means 0 class, belongs to 0 class, and this belongs to 0 class, and D7 belongs to 1 class. Okay, so based on the voting, we can say that we have 2 class in 0, means 2 samples in 0 and 1 distance is 1 class. So we can say that this sample will go to this 0 class. Major voting. Okay, so this is the idea of KNN. So how we will perform this idea using Mapreduce? How we will implement? Okay, so here you say that this is the constant data set. This is not going to change. Only change is this one. Okay, so we will broadcast this data set to each node in Mapreduce or Spark. Okay, because on each node the availability of this data should be there. So that if new data will come, it will compute the distances, all the distances from the training set, right? So it will be broadcasted to each node, and this node will go, this data set will go to each node and compute the distance and emit. So mapper will do the distance calculation task in map. We will calculate all these distances and emit, means for sample 1 test set 1 we have distances like D1, D2, D10 suppose. Okay, so in this way we will emit from the mapper. Now suppose we have 10 data sets, means no 20 test sample, then this set 1. Okay, was TS20. Okay, now 20 sets, these results, intermediate result will go to the reducer, and what reducer will do? Reducer will do the sorting on the distance individually, and based on the k value it will find first 3k and try to find the indexes, means in which class they belong to, and based on that belongingness they will assign the class for each test sample. Is it clear? I think is it clear? Okay, so in this way we can implement anything, any algorithm using Spark or Mapreduce. So here, see here the case KNN is there. So for each testing sample SI, what we will do? From the training sample, we calculate the Euclidean distance between a test sample and a training sample. Okay, accumulate distance values for each training sample and emit the distances like this. Number 7 you can see, right? Distance 1, distance 2, and distance j. Suppose we have j training samples. Okay, so this is for map and this is for reduce. For each testing sample si, what we will do? Sort the distance value in ascending order obtained from the key value pair. Select the k nearest neighbor to the testing sample. Assign the testing sample to the most frequent class. How? Based on this logic. If tie occurs, then sum of distances of the neighbor in each class computed. If no tie occurs, move si into the minimum sum, else move si into the last minimum sum. In this way, any logic you can apply based on your requirement. Okay. So this is the implementation of KNN on Spark. In a similar way, we can also implement artificial neural network ANN on Mapreduce and Spark also. Any doubt? Any confusion? Naveen ji?
Yes, sir. Yes, sir.
I think we can stop here. So
Okay, sir.
these are the
Okay.
basic things we have.
So-
So if you have any doubt or any participant having any doubt or any question, they can tell me or message me anytime.
So participants, if you have any doubt or any query, feel free to ask to sir. Okay. We would have still 5-minute time. So if anyone has any doubt,
Okay.
we
So
are
the
seeing-
same thing we can do on the cloud. So this is the application of big data analytics in cloud. Because we are storing the data on the cloud only. We don't have this type of machine individually, or we are not going to invest. We can take the lease from the cloud resources and we can do the same thing on that. Okay.
Okay, sir.
So
Participants, I am requesting again from the KLU, from the STTP team side, if you have any query or any doubt, feel free to ask. Anyone? Either you can use, you can ask verbally or you can use the chat box. So, okay, sir. It's me, sir. On behalf of entire STTP team, I would like to thank you because you have given your very precious time from your busy schedule to make this FTTP very informative, fruitful, as well as success. So thank you, sir, once again. We will ever remain grateful to you for your such kind of valuable inputs, guidance, and encouragement in learning the interesting concepts like big data analytics in AWS.
okay, thank you, participant. Thank you, Naveen.
Okay, sir.
So can we stop?
Yes, sir. Yes, sir. Sure, sir.
Okay, thank you.
So participants, we will again resume and we'll start the session, next session at 11 a.m. sharp. So now this is a time for a virtual tea break. So we are again connecting for the next session at 11 o'clock sharp. Thank you.
Good morning, everyone. Welcome to the final session in our training program, Practicing Cloud Computing with AWS. Today we will look at something regarding S3 storage because we've already done in-depth EBS storage. We have covered, you can say, pretty much in-depth yesterday. Now we will look at S3 storage, and it's actually reasonably less complex, you could say, much less. But being one of the most popular and essential core services on Amazon, we should take a look at it and understand exactly how S3 storage actually works internally, and also backups and snapshots, which we had taken a look at in our first session, the first day session. We will look at it in, we'll do a few demos, couple of demos on that to get the hang of it. Let me share my screen. Just a minute, please. Right. So my screen is shared.
Yes, sir. Yes, sir.
Right. So I hope I'm audible. If I'm not, please send me a message on the chat. Let me know.
Sure, sir. Sure, sir.
Okay,
Definitely,
great.
sir. Definitely.
So what we were doing yesterday, we were looking at EC2 storage type. Over here, we look at backing up volumes. And along with that, we'll also take a look at our case study. And we'll backing up volumes, of course, we're looking at EBS snapshots, basically. All right. So in this module, what we will do is we look at the different options we have for backing up data from EC2 block storage volumes in particular. But we'll also take a look at simple storage service and how it's actually put together. A little bit more informative way. Anyway, as we all know, like backing up data is important. Since a lot of things can actually go wrong in a real world like production environment. The most durable AWS service is called S3. Now we mentioned this when we were talking about object storage. Now S3 can provide much greater durability than any other volume type. So that is why we use it to store our backups. So now Elastic Block Store has an integrated way of doing this with the help of EBS snapshots. You're probably wondering what EBS has to do with S3. You see that storage is on S3. So whatever we actually back up actually goes to S3. Even if you can't see it, it actually goes to S3. That's why we are going to this. We are looking at S3 in particular. So we're going to see what snapshots are and how we can create and use them. Now, doing snapshots manually is actually not the best solution since we want to focus on developing our project. And in anything, nowadays the trend is towards letting a framework, which of course AWS is not a framework, it's a platform. So letting your framework or your platform handle all the routine tasks. Frameworks actually, they shift all the repetitive tasks and the boilerplate code is shifted to a framework. For instance, like Spring will handle all your connections and even your transactions. If you simply declare them, you don't have to, the repetitive code The copy and paste code, the boilerplate code is all removed with the help of a framework. Similarly, a platform will ensure that repetitive tasks like backup and restore, for instance, is like that. That can be shifted to the platform, so it allows developers to focus on the business logic rather than maintenance and cleanup. There is one thing, data lifecycle manager. This helps us in automating the process. And also, as we all know, the trend nowadays, like for instance with DevOps, the trend is towards automation. Not only a trend, it's becoming ingrained. So automation can be done in a variety of ways. Data Lifecycle Manager is a very good facility provided by Amazon Web Services for automation. Now, all these concepts will be like I remember a case study from yesterday. They'll be very useful for our Globomantics client. So the startup is doing great for now, but they started to use auto scaling groups, and we've seen how powerful auto scaling groups are. You remember we terminated an instance, and our auto scaling group, once it performed a health check and found that the instance was no longer available, it created one and deployed it. Our downtime was negligible, maybe a few minutes, at least, and that's
Well,
for us on the free tier. So now Globomantics has realized that people from other continents can also use their services. So it could be great
sir,
if we could. This is cross replication between regions. If you can
Steven,
actually
sir,
replicate those instances in other regions, that would be
Steven, sir.
great. So they also need to know a way to back up their EBS volumes in case something happens to the instances.
Sir,
We'll find
it's
the
Naveen.
answers to this as we progress to this module. So S3 object storage. It's
Why
finally
is it?
time to actually introduce it properly. So S3 uses a flat storage system which stores data as objects. We've
Sir,
seen that
sir, it's
actually.
me, Naveen, sir. I have a question, sir.
Yes,
Without,
sure.
sir, I have a one dot, a small
You're a
dot.
little soft, Naveen.
Sir. Now I am raising my voice. I try to raise this.
Okay.
Uh, sir, it's my question. Sorry to disturb you,
No, no.
but
Go ahead.
I want to catch your such kind of precious time. That's why I try to say. Sir, say suppose if auto scaling, we
Okay.
use auto scaling for the provisioning or deprovisioning the servers, but say suppose that for a day or for 12 hour, if the auto scaling is not working, then in that case, what happens?
If the auto scaling doesn't work.
Doesn't work.
Oh,
Yes.
okay. Okay, okay. That is what we actually, in that case, we have these inbuilt checks and safeguards. We have to configure events. And what Amazon Web Services uses is something called CloudWatch, which monitors all your services, also logs it. But mainly, you're talking about monitoring. So in
Understand.
this case, yeah. So in this case, we have to set up a CloudWatch event on that auto.
Sorry, your voice is not audible. Stephen, sir.
Print 7.
Steven, sir, your voice is not audible, sir.
Hello.
Sir,
So
coming.
back online. I think that there was a power fluctuation, which actually it should still stay connected even then because of the backup is power backup is there, but maybe it went off for a few minutes. So the router started up again. So can you all hear me now?
Yes, sir. Yes.
Okay, that power fluctuation happens. So then the the router started up again. It takes a few minutes to come back. That's what happened. It shouldn't actually, the power backup for some reason didn't work correctly. All right. So we're just going through storage service. Now, so we all know data stored as objects. Now, what has this have to do with EBS? We're coming to that. So you see how it all ties in together. So use cases for S3, you understand, is content delivery, media hosting, and static website hosting, which we saw yesterday. So as you can imagine, S3 is often used to assist various applications and services. So, but over here, actually, we are focused on the storage solutions for the EC2 service. Now, why are we talking about S3? Because S3 actually, look at the last point over here. S3 provides us with the ability to back up EC2 block storage. Okay, this is why we are going through it. S3 provides the facility. From the interface, from the console itself, we can easily make our backups and create our snapshots and all that, as we are going to see. But S3 provides the facility to actually back up EC2 block storage. Now, let's take a look at the S3 object. We got text files, videos, images, basically any type of data can be uploaded to S3. So after we upload the file, S3 containerizes it to an object, no matter what you sent up. So yesterday we sent up an image and an HTML file that is containerized to an object. You saw in a bucket, we had a bucket, right? So then within that bucket, we put whatever we uploaded was containerized like as an object, each file. And each file has its own set of properties and its own set of permissions. So to access it, we had to set the permissions and the properties, not on the bucket, on the particular objects that were uploaded. So an object is the core building block of this service. So each object contains a key and the version ID, right? So key is usually just the name of the file that we uploaded. Like see in the example over here, we have file.txt. But anyway, we can rename it also. That is there. The version ID is the unique identifier. So the reason it is called version ID instead of just ID is because S3 supports versioning as we saw yesterday. We can enable or disable versioning. That's up to us. So if we got more versions of the same file, like let me give you an example. Maybe you're creating a different versions or maybe even source code. Everything is not static file web hosting. So you can upload different versions of maybe a program, a Node.js program. Fine, with different configurations for maybe test development and production environments. So S3 needs a way to differentiate them. Of course, the object contains the value of the file we uploaded. Value is the data itself. A metadata is just a set of key value pairs, like the creation time, the storage class, the size and bytes, content type, and stuff like that. So version ID is also stored in the metadata. It's not mentioned in the slide, but version ID is also stored in the system metadata. So users can also define some entries manually. So the storage class defines how we want S3 to treat a specific object. Now, it offers different storage classes for different use cases, like as we saw before. For example, just as a recap, if you have some infrequently used data that needs to be stored, we can assign it to some storage class that will cost less, but you will need more time to access the object. We saw that yesterday. You can't access it instantly. Some you can access in minutes and seconds, some will take hours. So it depends on the kind of storage class over there. Then finally, we have the access control information. Now, these are the permissions that, as we saw yesterday, we have basically two types. We have access control on the object itself, and we have ACL, that's access control list. And the types of permissions are basically read and write. So for generalized users, like of course, like with the website, you just need read access. So that's what we put on yesterday. Now, before we can upload data on S3, we need to create a bucket. So a bucket is our own place on the S3 service, which we can use to store objects. It has no predetermined size. We pay only for the storage we use. So buckets use like a flat storage system, which means they don't group the data in folders like file storage. If we want to group objects, we can prefix the key of an object with the same name. So this will look like a path, a path name in a regular file system, but it's actually just an object key. So both of these text objects, for instance, in the slide in front of you, they are on the same, they're on the actually the same level, let me say. They're on the same level as any other objects in the bucket. Now the folder is just added to the key name to make it seem like they are placed in a separate directory, but no. Buckets are also region based as we saw yesterday. So we usually create buckets in the same region. And there's one more thing, it picks up when we actually create an S3, whether no matter what region you are currently working on, if you click on S3 and you open the S3 dashboard, you notice that the region changes to global. Okay. So we usually create a bucket in the same region that contains our resources. Why? Because latency is a factor of distance. So if you create a bucket in the same region, your network latency will be lower. So that is advised. Now, the most important thing about S3 is extremely high availability and durability. The numbers actually depend on the storage class. This should actually be S3. Okay, I will fix that later. So as we saw, an availability of 99.99% and a durability of like, wow, 11, we remember we talk about it in terms of number of nines. So over here, durability is basically 11 nines, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about that. So just like the EBS volumes replicate inside of the availability zone, so S3 buckets replicate all over the region. So this makes them more durable and reliable. So if we really want to make our data as secure as possible, we should consider backing it up on S3. Now, EBS snapshots. To back up now EC2 storage on S3, we will need to utilize EBS snapshots. So a snapshot is basically a point-in-time backup copy of an EBS volume. Now here's the thing, we store the snapshot in S3 to make it more durable because S3 durability, as you've seen, is on 11 nines. So this is the relation between the two different types of actual storage. So if something happens to the availability zone that hosts our EC2 instances, S3 will keep the backup safe because the data will be replicated across the whole region. And when the problem gets fixed, then we can simply restore the data from the snapshot on the new EBS volume. Now, so you see, you have many checks and safeguards in place for all this. So in the same way, like to answer Naveen's question, like if you create an autoscaling group and what goes down, and if it goes down for whatever reason, if you set up your backup policy properly, you will have the snapshot. The snapshot, the durability is over there. You will have the snapshot, your data won't be lost. And once that issue is fixed, it could be because that region itself, which is a very low probability, but that region itself will the possibility of going down is very low. But not only that, for an autoscaling group, generally it spans multiple availability zones. Generally, we can set it up like that. So if one actually availability zone goes down, the other will still be available. So in that case, we can put those precautions. But anyway, there's also Elastic Beanstalk, which not only will is an Amazon managed service, which will create our load balancers, our instances, our snapshots as well, our availability groups, and that is an Amazon managed service. So if we use the Elastic Beanstalk for this kind of provisioning, which we're going to do next actually, you'll see that it is you know your your uptime will be very high, very negligible chance of a downtime with Elastic Beanstalk especially. But we're coming to that after this. Now, so okay, when we create a snapshot of an EBS volume for the first time, all of the data blocks on the volume are stored on S3 data blocks. So snapshot only contains references to these data blocks. So let's say something like this. Let's say we have these two data blocks inside of our EBS volume. Suppose, okay, here's our S3, here's our EBS volume. Now, when we create the first snapshot, the data block will actually when we create the first snapshot, the data block copies are backed up inside of the S3 storage. So you can see where it goes. Okay. So see the little checks at the bottom over there. So our first snapshot only contains references to these data block copies. Okay. So once again, when we create the first snapshot, the data block copies are backed up inside of the S3 storage. Our first snapshot only contains references to these data block copies, and that's those checks over there. Now, each reference inside of the snapshot is pointing to a backed up data block of the same color. All right, so far. Now, let's say we added another block and we modified one of the existing ones. When we take the next snapshot of the same volume, only the changes will be uploaded to S3, not all of the data blocks. Because changing the data block will be a lot performance wise, but we are actually simply uploading the changes. So like this. Okay. Now this modified block will be treated in the same way as a new block since it's different from the old one. So snapshot 2 will reference those two new blocks, but it will also reference the old blocks. Except the one that was modified. Now the one before the modification is still on S3 and is still referenced by this first snapshot. Okie doke. So snapshots are here to remember the current state of the volume. That is why they only contain references to those blocks that exist at the time the snapshot was created. So if for some reason we don't like this modification on the block, basically what we want to do is roll back. But we're doing it on data, not transactions. We want to revert to a previous kind of snapshot. So if you don't like a modification on a particular block, we can just use the old snapshot, which is pointing to the old version of the block. All right, now let us add another block and we'll remove one of the blocks from the volume. We are here. When we take the third snapshot, only the block will be uploaded. since we already have other blocks on S3, so incremental backups exist so that we don't have to upload all of the backups every time we create a snapshot. That's inefficient. So if we have some of the blocks already uploaded, why would we upload them again? So snapshot 3 will also have references to all of the blocks except the one we deleted. So data blocks still exist in S3 because the first and the second snapshot are actually pointing to it. Let's remove the first two snapshots. Now, after the removal, S3 will check which data blocks are not referenced by anyone. So look at a snapshot and look at what it exists. So those data blocks will be deleted. But a lot of them will stay because the last existing snapshot, which is not deleted, is still referencing them, right? Get it? So the ones, those, the snapshot 3 is referencing these blocks, so it stays. The others will vanish because it's not, there's nothing referencing them anymore. This is how it was. Then snapshot 3 is the only existing one, and this is how it, this is the only references. So snapshot 3 has references to them. So we, those blocks will stay in S3. Now, when we have to back up a large number of volumes or manage a lot of snapshots, we can use like the data lifecycle manager, also known as DLM. So the service is specifically made to automate the backing up of EBS volumes. Now we use policies. We took a look at it, but we'll take a before. We use policies to define the backup schedules which specify when we want the snapshot to be taken. So the policies do what? They actually automatically manage the expiration date of the snapshots. And of course, we can also, we can also define when the old snapshots can be removed because they take up space and then you'll be paying for it. Okay. So what we are going to do, we are going to recommend these solutions to our global Mantis clients. So backup should be made daily with EBS snapshots. All right. So over here, let's go through a little demo. Let's go down to our, you can open your console and let's see what we have. All right, so we will need, let us create a new EC2 instance. All right, we'll create a new EC2 instance and we'll work from there. So everyone, this y'all can do in your sleep by now, I'm sure. We take a default free tier AMI, of course, and then we'll choose, of course, the T2 micro instance. This is networking. Then the root volume will be 8 GIB, not gigabyte, general purpose SSD. Okay, then we can actually a tag we should give. So if you put it as name caps, not lowercase, then it will actually put a name to your instance. So we'll call it something like that. This is good enough. Now we can launch it. That should be good enough. So let us launch our instances. Snapshot INST. So you have to put it when you're doing your tags, just remember uh, the name has to be caps. Then it'll tag it. So then it'll come over here. It'll help you, with organizing your stuff. Running already? That's good. Just one thing I like to remind everyone again, once you all have finished, there's a lot of stuff. Once you have finished doing your work, clean up because you're on the free tier. So don't keep all these instances. If you're working on something, fine. And then once you are done, delete everything, starting with your instances. And starting with your instances and then go from there. So delete your instances, delete everything, and just clean up everything. Leave whatever's essential only behind. Don't keep instances running for no reason. The instance is storage capacity and is paid. You can be charged until it's terminated. So once it's done, terminate it directly, and everything else also clean up. So you'll have a fresh workspace every next time you sit down, and you can always recreate it. It's just practice. Whatever you need, if you want to go through something, you can always recreate it, but don't leave it hanging around. Clean up everything, top to bottom. A few things actually, like key value pairs and all, that's fine. And certain things, your Lambda functions, until they're used, they don't incur cost. But not instances. Clean them up straight away as soon as you're done. So let us see what's going on over here. So let us see, we have a root device over here. Here's our root device name. Our block devices are here. Here's our volume. Right. So this is our root device name. Here's our volume. And as you can see, the device name is this devxvda. It's been attached. Here's our device XDA. Okay. So this is the root volume of our new instance. We can actually go through it. It'll be over here. I didn't want to take you over there. I just want you to have some familiarity with the interface. And so you can focus on the task at hand. Anyway, We only have one instance right now, but imagine if you had a lot. How would you actually find which volume you are actually looking for? Okay. So anyway, simply click on this. And here we can see this is our snapshot instance, which has come up over here. This is what has come from this in particular. Okay. It's much easier because we don't have in any case any. All right. And we got all the information over here. A volume ID, size, the volume type, of course, GP2, the IOPS, which is 100. You will understand why they know throughput because this is SSD, the snapshot that was created. The state is in use, it's not encrypted, and so on. So now it's time to create a snapshot. You can see we just go to it was an overview of like a lightning tour. We did nothing else. So we click on the actions button and we can create a snapshot. Give it some description if you like. This will appear over there. So just for identification purposes. Okay, so now what name did we actually give this? We gave it as whatever. So now we actually got a way to actually create a snapshot. However, don't do it right now. Let us go back over here. Come back to our instance and let us actually choose stop. We're not terminating, we're stopping it. Now the instance will be stopping. So now why did I do that? Actually, this is the best practice. You understand that when we're creating a snapshot, we're creating a snapshot from the root volume. So ideally, we should actually first stop the instance. This is the best practice. Okay. Now, since the root volume obviously is the most important volume of the instance, there's always something happening, whether you're actually interacting with it or not. Something is always happening. If you just create a snapshot from it without stopping an instance, you know, we can potentially lose on some data. Potentially. So good. Now it's stopped. Very great. So after the instance is created, we can actually go back to root volume and we can go on create snapshot. And now we can like that, right? Anyway, write some description and that's about all you have to do. Let's see, this should be so let's create our snapshot. That's fast. Snapshot. Now in our description, we have a snapshot. Let's go see what it is. I think maybe just still be creating. Let's look at the details of this. Now, this snapshot, you would think that you will be able to see it in S3, right? No, that won't happen because the snapshot is actually backed up in S3. That is true. Just not in the public user visible domain, but it is backed up in S3. Only the buckets like we create, like what we have done yesterday, that is visible, not the snapshots. Availability zone, this. Okay, so that seems all right. And our instance state is stopped. Just a second. Is something seems a little off over here. Oh God. No wonder I can't see it. It's that filter was over there by my filter was over there. So just be careful. This always happens. These filters come if you click through, you know. If you go directly, there won't be any filter until you, but if you click through. So here's our snapshot. As you can see, our demo snapshot, first snapshot. So the name is always nice. Just remember, give your names a little bit more effort and we can put our tags down. And here's our capacity. This is, as you remember, the volume capacity is over here, 8 GIB. Our snapshots, the volume is also 8 GIB. Cool. So that is where we have now actually created our snapshots. You can also you can also do a lot of stuff programmatically. If we had more time, we could go through it, but maybe some other time. Programmatically also we can create snapshots, but we need the Amazon AWS CLI actually installed first. but that is also very straightforward. So the last thing we'll do is actually automating snapshots with the DLM. So this is what we'll do. We'll do another demo. We'll automate the snapshot creation. You have to be careful with this now. Once you're done with this exercise, uh, whatever you've configured, then delete it. Otherwise, it'll start backing up your snapshots and then it'll override your console. So you can automate it. You can also delete all snapshots. And this we actually do with our data lifecycle manager. Now see the last entry, create tags on volumes. Now over here, tags are not generally necessary. You and me are using it for identification purposes, so we don't get lost hunting through the console through, all the different instances and stuff that's been created, and we forget what we did actually last. So that's why we put our name at least. Huh? Now, the data lifecycle manager, it expects you to have tags on the volume. That's how it identifies it. Which one do you want me to kind of monitor? You have others, like as I was talking with Naveen, when you have this auto scaling groups, for instance, you have also another thing in you can create the CloudWatch events and you can set them and they will monitor your services. Now we are looking at data lifecycle manager as a sort of monitoring, like a little security guard. So he's going to monitor snapshots and is going to automatically back up and even delete all snapshots. No restoration. That's restoration we need to do. But it can delete all snapshots and it can back them up at regular intervals, on scheduled times, as we wish. So let us go back to our console. So what we are looking at actually and we're interested in is actually automating our snapshot creation. So that way we won't have to think about when we should create a snapshot or how long it has been since the last time we created a snapshot and all this rot. That headache is gone. So we also want to delete the older snapshots because we want to save on storage, of course. Once again, this snapshot that we have in front of you, it is there on S3, very much. It's just not accessible to us. What we create on S3 is there, but this is created on S3, but not in the visible domain. You can access it through the console like we are doing, or programmatically also through the CLI. That is also there. Whatever we do on a console, if you're quick and fast enough and you put in the effort to write the scripts, you can do it from the CLI. But that is a separate course because you have to write the scripts itself. Anyway, so a data lifecycle manager is an automated tool which is made specifically. So that's why we are using it. We're not using something like CloudWatch. In this demo, we're using the DLM. It's made specifically for managing EBS snapshots. So it has policies which define when and how often the snapshots should be taken and how many snapshots should be stored on S3. Now DLM uses tags to identify the volumes it needs to back up. So here's our volumes list. Let's go to over there 1 second. Here's our volumes. This is only one volume we made. Okay. So here's our root volume. I shouldn't have given it this. Let me see. I hope it doesn't jigger something up. Okay. It's not a snapshot, it's a volume. Snapshots are here. Okay, so let us apply tags on this. We got no tags over here. And then we can just go add edit tags. Huh. I think that's okay also. We can just take the default, it's just taking the name. That's okay. That's also okay. So it can be anything, the tag. Nothing surprising about tags, but it has to differentiate the volume from the rest of them. So this is the only volume actually, and it's also the only volume which has this tag, volume inst. Now data lifecycle manager can be found. We have it here. Let us see. Data. Here we are. So in the EC2 menu, now we can create. So simply create on this next step. We start to create a EBS snapshot policy. And we are going to do it on volumes only, right? We are actually backing up the volume. So target volumes target, write some description like daily backups. Some description you give it. Target volumes, of course, are those volumes we want to back up with DLM. Now DLM finds these value volumes to the tags. Okay. So we have name. And the name is it should be volume inst, right? Right. So this is the tag that we had put just now, right, on our volume. So we've targeted it. Okay. Let's go down, give it some description. We can create a role, but for now we can actually leave it. We must have the policy enabled. We can click on next. Now let us see what's here. Values required. Okay. This is very straightforward actually. Policy status must be enabled. Schedules. Leave the schedule name as it is, that's fine. Now we have to define the interval in which the snapshot will be taken. So start time will define when the first snapshot will be created. Retention rule defines how many snapshots we want to keep. Say something like 2. It's just for demonstration purposes anyway. Okay. So when the DLM, actually, this is what is going on. When the DLM creates the third snapshot, all right. When the DLM creates a third snapshot, it will, the oldest one will be erased. So people will keep 5 maybe. It depends on the organization, on the team. So anyway, you understand that if the DLM creates a third snapshot, the oldest one will be deleted. So this way we have save on storage, and we also have the last 5 snapshots. Okay, and tagging. Now, what this actually does is that it adds a tag to every snapshot after it gets created. So over here, we can simply say name, and then we put a value true. So this way, actually, we can know which snapshots belong to this specific volume. Anyway, everything else is there. We got a default IAM role. We got an enable policy. I think we want this policy to stay enabled, and that's it. Can create the policy, and that's successfully created. So now, once we created a policy, the lifecycle manager will manage the snapshot creation and deletion for us. That's how we manage it. Because we have the retention, all right? That is key. The retention is key to this. Now over here in our snapshots, obviously we are not going to see it right now. If we leave this policy at place, then we will actually see it tomorrow. So our first snapshot will still be over here. Okay, so that's what I wanted to take you all through. So as you can see, relatively simple over here. Now there's one thing I'd like you all to try out. Just yesterday we had these supporting materials. We got demo 2, which we already done. No, demo 1 we've done. Demo 2. Now this one I want you all to do as an exercise. You all create a bucket, and your bucket name has to be inserted over here, just to give you some practice with policies. And if we come over here, we go down to S3. This is the first and only homework that actually you'll have. Just a little bit of practice regarding this. Now, as you'll know, let's take something that we have over here. We have permissions. Now, we have actually done permissions in. We have actually set it. We have configured it. As you all saw yesterday, we configured it, but we can also set it via the policies. So find this edit bucket policy under, you create a new bucket, you set these policies, all right? You upload, everything that we've done stays the same. Create some static website, upload an image or upload an HTML file. And once to set the permissions, you don't do it through the console. You open this policy over here, substitute your bucket name and insert it over here. Make any other changes that are necessary, as we did in yesterday's code walkthrough, and you're done. Okay, so just do that. What you'll get a little bit of practice with policies. Editors are related to IAM, of course. So they're very useful. They're very useful, and especially if you're working in a project environment where you don't have the time to go and manually configure every single policy for every single individual or role or bucket or whatever. You write down a policy editor, you can apply it in whatever situation you want. So just to give you a little exposure to that. Okay, So now what we are going to do, we are going to look at something called Elastic Beanstalk, which is very interesting. And this is actually fully managed. You'll be pretty surprised at how realistically it's managed by Amazon. So AWS managed. A lot of the stuff we've been creating is not AWS managed. We've done it on our own. But to have something actually managed by AWS, of course, large organizations generally have all their configuration and the setup. The teams already set it up. It's not valid for them, but others, it could be nice to have something that's actually managed for you. Okay. Okay. So let us go through this and we'll do a couple of demos to see how it runs. If you all will please excuse me for a minute, I'll be right back. I just need some water.
Sir. It's not only the drink break for Samuel sir, for us also. Sometimes we should take a drink, little bit. It will keep us energetic. In the meanwhile, I request all the participants that if you have any problem, any query, any doubt regarding the current session or the previous sessions which have already finished, you can ask the query, okay, or you can use the chat box to write. Okay, we all from the STTP team will try to respond for your each and every questions.
Okay. So what we are looking at is deploying applications on Elastic Beanstalk. I think what we will do, we'll just go to, it'll take a little time for this to set up. So let's do that now. And then we can actually go through, the concepts, approach it conceptually. All right. So what we'll do, we'll deploy an application on Elastic Beanstalk first. So we'll do the demo first, actually. And we'll check out all the things that it sets up for us. as well as like some common management features that are built in, like log access and performance monitoring. So let us do that. So here's our services. This is a convenient way you can just search for it. Let's click on um, Elastic Beanstalk. Let's go to that console and then select create application. So just recall that your application is actually the larger container for your environments, right? And your versions. Call it anything you want. Application tags. We just put a name. Oops. Name. Hmm? Yeah. Okay, it's very, we don't actually need this. Now our platform, let's choose our platform. Let's take something. Yeah, many platforms you can actually choose. It supports a wide variety of platforms like this. All the way from .NET Core and Docker and Glassfish, Go, Java, all the way down to just a Tomcat server. So for our purposes, let's do Node.js. This is the recommended, that's fine. It's Amazon Linux 2, which is the normal server that we take. All right. And this, as a matter of fact, we can upload our own code. That is true. We can upload our own code. And I think we can just go with just create a sample application. And you'll see that it will start. Now, Amazon's got plenty of sample applications for each of the platforms that that we can use simply to get started. So we can actually go over there, as we can see. And let us see now. This is AWS Elastic Beanstalk. Uh, we want the sample applications. So if we go over here, this is all the tutorials and all that stuff over here. This is a very good reference, by the way. Let's take our Node.js. Do that from there. And this is how it's progressing so far. You can take it yourself. Otherwise, I'll just leave it over here. By the way, your GitHub is updated with everything over here except for this, but that y'all can pull from the net. So it's updated. So after this session, please update from GitHub for our last session. Let's go back and see what's going on over here. So here is see. Now look at what it's creating. See, it's using, this is the region, which is actually mine is Ohio. It's got a target group is created, a security group. Its environment health is transitioned to pending, very fine. It created an auto scaling group for us. Now it's creating an instance, waiting for it to launch. It's created this is the group policy. Events. So you see, this is Naveen and everyone else also that if when you have something like this created, Elastic Beanstalk manages everything for you. All this that we would take time to actually create, wouldn't we? It would actually take time. So here's it's actually already done. Of course, we just use a sample application for our purposes, but we can also go and we can take it from upload our own sample application that is there and deploy that. Okay, for this sample, it created actually both. For this, it created our application as well as created um, application environment. So this seems done, it's healthy. Here's everything done. So it's got environments as well as applications. If we click on applications, we'll see this over here. Here's our demo app one. Health is fine, the platform is supported, and the running version comes underneath the application versions over here. So we can actually revert if you don't, some problem happens, which always is a possibility, something happens in deployment, we can revert back to another version, we can redeploy. So it maintains these versions for us as well. That's really, really cool. So let us go back to our applications and here's our demo app. You'll actually need to click on it to see what it is. This is the URL that it has. Okay. Now I could actually, just for the sake of a demonstration, we could create a new environment. All right. Just create it for now. And then, no. Sorry. Just go back to applications. If I create a new application, maybe I'll call it demo app 2. Okay. Now if I actually create it, you see there are no environments actually defined for the demo app 2 application. This is done very consciously. So what I would do in this when I would actually go through this and create like a development, a test and production environments. Okay, if this was my application that I wanted to work on. So under application versions, I could also upload various versions of the application that I would want to apply to different environments. Okay. Let's go back to our cell now over here. Let's go to our sample application environment and see what's going on. So here's our sample application environment. So far, so good. So here's our, okay, we have all our recent events is over here as usual. Show all. And let's take a look once again. Anyway, we've seen this. It's got created the security group, the auto scaling groups, or it's got the CloudWatch alarm. It's created a load balancer. If we go down, uh, and it's just instance deployment is completed. Should be okay. All right, so it seems that everything's all right. It's created, it's got done quite a bit actually in a short period of time, right? So now if we come over here and if we click this, and there we have it. We have our first AWS Elastic Beanstalk application is running. This is, I've taken it, you know, you can bookmark this page. This is from here. Oh, it's just from the, you just do a search for Elastic Beanstalk and just take a look at what you call it. Just pull one of anything you want. You can use Python, whatever you want, you can use. Now on the left-hand menu, this is basically a running Node.js application. That's what's been deployed. On the left-hand menu, you have some additional information we can access. Let's take a look at logs, for instance. So under logs, you can see that we can take the full logs from the instance, which I don't want, neither do you. Let's take the last 100 lines. If we actually say download, it'll open it up right here. And over here, this allows you to see what is going on with your instance, as well as with Elastic Beanstalk. So everything will be over here. Our error log is empty. That's a relief. Here's the engine log. Now let us go back once and let us look at monitoring. So under monitoring, you get, this is your overview. We can see different things like CPU utilization, the max network 204. Let's go down here. Right. So we got all that, CPU utilization, network activity, etc. So for you to monitor, because there is a possibility for anything to go down. So we have to put our checks and safeguards in place. And the only thing that we have, we can configure stuff to respond. Like an auto scaling group is configured to actually respond to an instance going down, being terminated unexpectedly. But there are other situations where we can, how do you say, uh, we have to monitor it, and in the event of failure we have to respond appropriately. So this monitoring and logging is very essential part of any application, not just on AWS. We can try something over here. We can try to update our application. You know, if we click on configuration, I clicked on configuration over here. We can sort of, let's see, we can change, let's look at, suppose we change our deployment. Let me see, come to capacity and click on edit. Okay. We'll change our deployment from single instance to like multiple instances. Huh. And the load balancer, as you saw, has already been created. Then we can actually, the different scaling options, we can also deploy a new version of the application. We're in the configuration section now of our Elastic Beanstalk environment for our demo application. Okay. So let's change the capacity of this. Let's go to edit and we'll change the capacity from single instance to multiple instance behind the load balancer that's already been created. So come over here. Okay, this is wow. Initially to a single instance, this is the only other option. Let's keep this as a minimum of 2, maximum of 4. And then you can choose on-demand instances and all just for the purposes of our practice. This is all we are going to use. We can change the instance type and the AMI and availability zones. We can also set different scaling triggers. This is when the network is out, for instance. And this is how you interpret your different metrics. So we can also set our environment to like scale up and down based on a specific metric, like network activity or CPU utilization. You see, keep the default for now, or disk input output. Anyway, we won't set any specific triggers for now. But just know that this is actually linked to an auto scaling group. And now a scale down increment over here is by default -1, which is fine. All right. We also have the option to select time-based scaling where our instances will automatically scale up or down at a certain time. All right. Now we can apply the changes. So let's see how this runs. So Elastic Beanstalk is now taking a previous environment and it is updating it. So what will it actually do? Basically, it's going to anyway, you understand that basically it's going to provision the load balancer. Then the auto scaling group. I set a minimum of 2, so it should spin up another instance. All right. And then so let it spin up and then we'll see.
In the meanwhile, sir, I want to say that, say suppose I have to maintain a canary deployment strategy along with this auto scaling group.
Uh-huh.
Will manage. Say suppose versioning management we want to do, like canary
What
type.
management? Sorry,
Canary
say that again.
canary deployment, sir. Say suppose in the auto scaling, what we want to do, uh, we don't want to take the risk of new version based software deployment.
Mm-hmm.
We want to integrate that scaling, that type of scaling with Beanstalk. How do we do? Just, sir, theoretical explanation I require.
You mean you don't want any new versions to be deployed?
No. I want the new version should be deployed, but it should be in in such a manner so that say suppose we don't want to convert our entire deployment into the new version based target group on one night. It, I want that it should be done in a fragmented way like that, so that we will easily remove the servers from the old target group and we will add the new servers in the new target group that contains newly versioned software.
Okay. Okay.
Means everything is, sir, okay. I understand,
What
sir.
you mean is like the old instances with the auto scaling group, actually what happens is that you specify the instance,
Yes,
or
sir.
instances, and then it will, whenever the instance fails or terminates, then it will go down.
Yes, sir.
But if you have new instances which contain a different environment,
Yes, sir. That's the thing. Means that I simply
then
wanted to
how
say.
you add it to your auto scaling group?
Yes, sir. Yes, sir.
Oh, I'm not sure I don't think you can do it. Possibly you can do it programmatically, but otherwise, if we go through our normal way, you'll have to remove them from the auto scaling group and add Basically, you'll create another target group. You'll have to remove those instances and add your new instances to your auto-scaling group. In other words, you can create a new target group.
Okay.
If you want, like suppose you have one right now, we're using Windows Linux, right? Sorry, that Amazon Linux, Amazon's version of Linux version like 2.
Yes.
And then for our two-tier architecture, we use Windows Server 2019 Professional. So if you want to switch between instances, one running different kinds of software, you will actually have to create new target groups and you'll have to update your auto scaling group. That is that you'll need to do.
Or otherwise, say
Okay.
suppose if we are using Amazon
Programmatically, it can be done, but
Okay.
not via this. This would no. You'll have to actually create a brand new auto scaling group over there.
But this thing, I think, pinch my mind that can it be possible or no or not? Otherwise, it's okay.
There's no configuration options that I recall actually on for this kind of scenario where you can switch out instances because it's a very specialized case. So switching out instance, basically you're talking about switching out instances from an auto scaling group that I don't recall any configuration options available in AWS. Programmatically, you can do anything though, but
Yes.
you'll have to write the program. That is it. Or manually create it.
Okay,
When you
sir.
want to switch it out, you'll have to manually create it and redeploy. That will be necessary. So that yeah, I think uh, that's the only way.
Yes, sir. Okay, understood.
So
Sometimes, sir, I think I'm not understanding why such kind of queries will be come into my mind. But say suppose if
no,
this
it's
kind of
perfectly valid. It's quite possible that you'll need to switch it out at some times. That is perfectly possible. That is that is there. Not a big deal.
yes. Okay, sir. Okay, sir.
Okay, so our environment is actually finally created, I believe. Let us see. Health is okay over here on this. Let's go back to our environment and we can see this over here. That is also working fine. All right, so now the environment's finished updating. Let us actually come over here for a second. Let's go down to our EC2 instance. If we go to our instances, and here's our instances. Pretty neat, no? This is the only one we created before for our other demo. So our instances are created. So we got two running instances. Let's go down and see our load balancer. We haven't created a load balancer. I've actually cleared my environment. We never created our load balancer. Come down over here to our load balancer. And here's this. We got a load balancer which is sending traffic to those two instances. Pretty awesome, no? This is our Elastic Beanstalk. Now it's not there for everyone. Like in a real production environment, you have teams who will set up all this for you. But if you maybe you're short-staffed or you're handling everything on your own, maybe you are the IT department for a small organization. That is there. This is what you'll use if you need it. It depends on the use case, your requirement. Then it will actually come and we can go. Um, let's go see our what will we see? Let's see our task auto scaling groups over here. So here's our auto scaling group that was created. Let's take a look at it. All right. With the desired min and max levels are already been set up over here. So Elastic Beanstalk will manage all these diverse, see, desired capacity, minimum capacity, maximum capacity. So Elastic Beanstalk will manage all these different entities. Or you can go in and change the settings yourself also. It gives you a lot of configuration, but specialized configuration you have to do programmatically or manually. That is the only thing. So let us see one last thing before we quit for the day. If this might work. This is what I just downloaded. All right. Now what we can do is here's our index.html. Let's see what it's got. I wonder if this will work. Let's try. It has to be packaged actually correctly. You know. So we come in over here, we select everything, and we say add to archive, put it as a zip. Sometimes I had a little difficulty because I didn't package it properly. So it got confused as to what I was trying to do. All right. So let's go back to our Elastic Beanstalk environment over here. That's funny. Anyway, so I'll upload a new zip file over here. Okay. I can put in my own version number also. All right. And then if I say deploy, we have different rollback schemes as well on this. So I've just said deploy, but basically it will either deploy, it will roll, you know, it can yeah, all at once. If something fails, it can just roll back everything all at once. So here's our modifier, like hopefully this shouldn't be a running version. So here we are. So as you can see, our second AWS, that is the change that I made. So I just changed it first. Before it was first, remember? Our second AWS Elastic Beanstalk. Uh, these are the modifications that's been taken. It's been updated. Elastic Beanstalk has updated the application. So if you ever need to go back to a previous version, here's a previous version over here. These are all currently we have this sample application -1 deployed. You can also see it from the time. And this was made at 12:29. And this is 12. Yeah, yeah. All right. And if we just select the original, if we want to redeploy, then we can select the original version application. And then under actions, we can simply click deploy. I can even select, the environments where I want to deploy it, and that would redeploy the entire the sample application, redeploy it, the old one, to that environment. Okay, folks, so very good. We've seen Elastic Beanstalk in action, and how we can simply upload our code, then have Elastic Beanstalk provision servers, load balancers, and deploy our app. Then we've also taken a look at, all the built-in tools that are here for monitoring, for instance. We have all that available. And for checking logs and configuring our environments, as well as how to release new versions for our application. So the next few sessions will be the next session will be taken by Mr. Charan
Yes,
from
sir.
Bytexcel, who you all might know.
Yes, sir. Yes.
So I won't be over there. And then, of course, congratulations. You'll have your valedictory
Yes, sir.
meeting, I believe, at 4:15. So all the best for that. You all have deserved it. And let me just leave you all with this, that what you all have done this week is actually phenomenal, because you all have done a deep dive into many core services as well as the extended application services. You all have also done that in Amazon Web Services. So you'll there's a cloud certified practitioner exam, which you'll know you'll are beyond that. You'll actually uh, on the developer track. Of course, it takes a lot more work. Maybe not too much work, but you have to put in the effort. If you think about it, you all could think about taking the cloud certified practitioner exam at some point, as well as the developer track, because this is what y'all now actually AWS developers. Y'all are not just bystanders or just simple practitioners. Y'all can call yourselves AWS developers. And let me also tell you this, that I have not created this syllabus. I was given it, and some of the topics that we have covered are not even from the developer track. They're from the certified architect, AWS certified architect exam, those topics. So you might not be aware of it, but you can take it from me. Y'all have also covered topics from the architect material, that the course material for the architect exam. So y'all have done a phenomenal job, and thank you so much, and all the best in your future career. And I hope you'll carry on with the AWS track. Think about going a little bit deeper into the development aspect. So good luck, and it's been really great having you all. I hope to see you all in some other training some point in the future. It'll be great to have you all on a training again. So thank you, and all the best, and good luck with the valedictory ceremony. So thank
But
you,
sir,
Naveen. I
on
think we're
behalf of
concluded
sir,
for
listen, sir.
today.
Sir, please give me a time for 1 minute to say something, sir. On behalf
Of course, please go
behalf
ahead.
of sir entire STTP team, what do I say? I think I am confused. It is so because whatever I will say about you, that will be very less. But the last, at least, I, I want to say that we all people, sir, will ever grateful to you for your this kind of but I can say that's your such kind of valuable as well as what we say such kind of encouragement for learning of such kind of interesting topics, sir. Because, sir, we know, sir, I think from the from all participant sides as well as from our team side, I assume that okay, everyone knows something. It's okay. It's okay. Everyone knows something, but there should be one time when we have to uh, deep dive into a concept, not only theoretically as well as practically, and for that should have a strong instinct to say that yes, this is the way this works, like that, which I have gained,
Yes.
sir.
Yes. Yes.
Definitely, I will say, sir,
Very true.
I have gone, I have got much what I say, sir. I'm still now I'm confusing to say what I can tell you, but I'm expecting that, sir. Please, you guide after this FDP to us if we need some kind of assistance.
Of course, definitely. I'm always available.
For this thing, sir, because, sir, so many things I have to say, but what I will say, participants, if any one of you wish to say something, you are also welcome. I will unlock, I'm unlocking all the participants. Anyone else wants to say something to Stephen, sir? Can say.
Thank you,
Also,
sir.
every day.
Sir,
Continue, ma'am.
thank you very much, sir, for your wonderful session. For a long dive, we have get a greater experience in the new field, this is AWS. Thank you very much, sir.
You're welcome. I'm very pleased. Thank you for your kind words, everyone. And you especially.
Anyone? But, sir, from my side, sir, I think I should have at least more time to say something to you, to ask some questions to you. But I know there is some limitation. That's why I couldn't do that. But
That is true. That is
yes,
right. I understand.
yes,
That
sir.
is fine.
But definitely, sir, in future, sir, I'm. I request you, so, sir, please, whenever we want some assistance from your side, sir, I'm expecting that we will give some guidance so that we all can pursue towards the AWS certifications, which is starting from the AWS.
Yes, I hope everyone thinks about it very seriously because y'all have done a lot of work and you go through what we've done is quite a bit. Y'all have not done it's not a small feat to cover so much in just 1 week. And if you think about it, and also, of course, everyone, I understand that everyone already is, has their own. In case you ever want to maybe have a secondary career as an AWS developer, or you want to switch careers, or actually get a new job, whatever it is, irrespective, AWS developers get paid very high. I wonder, y'all know that, I think. Or you might have heard about it, but believe me, in the software industry, some of the highest paid engineers are actually AWS developers and architects beyond that. So if you're thinking of switching to a job or a career that where you're paid the highest one of the highest in the industry, it's AWS, even more than full stack developers, as far as I know. So that is also a good incentive. So think about it in those terms. It does take effort because AWS, the development is not, of course, it takes effort. Any certification takes effort, but it's worth it. So think seriously on those lines. You'll have come so far. Why just leave it like this? You push on and explore some more. And upgrade, ramp up your skill sets till you are at that level and you can pass a AWS certified practitioners first, then the developer. And if you want to go take it still further, you can go for the solution architect exam. So I hope you all will think about it seriously. Besides the monetary aspect, it's your own personal satisfaction. You'll be, that's over there to take into account. So thank you, Naveen, and good luck to everyone.
Yes, sir.
And best of wishes for your future. And congratulations, your valedictory ceremony is at 4:15. All the best for that.
Thanks a lot, sir. Again and again, sir.
Thank you. Thanks, Naveen. Goodbye, everyone.
Bye, sir.
Bye bye. Take care.
Participants, our next session will be started from 2 p.m. So now it's time of lunch break. So at sharp 2 p.m., we are meeting again to attend the next session by Charan sir, who is also one of the experts in AWS and is an employee of Bytexture.
Good afternoon, participants. Good afternoon, Charan sir.
Good afternoon, madam. You hear me, right?
Yes, sir.
Okay, thank you.
Now I request one more speaker, Sri Charan Tadepalli Garu, Chief Technical Architect at Cloud19 Technologies. Sir has 20 years of experience in IT as an Director of Technology and Chief Technical Architect. Now I request Sri Charan Garu, please take over the session.
Yep. Thank you for a quick introduction, madam. I'm taking a minute and I'll start sharing my screen.
Okay, sir.
Just taking a minute. Yeah. Yeah. I think before starting, I think I'll just give a quick intro about myself and then I'll start sharing my screen. Myself, I'm Sri Charan Tadepalli and I'm an expert into cloud and DevOps and into backend technologies. Coming with IT industry experience of 20 years and then worked with different service and product level companies. I'm an ex Google and Oracle employee as well, and currently working with Cloud9 as a chief architect and director of technology. I think I'm very sure that the intended syllabus has been completed, but the last 1 hour I wanted to take for a special reason. Why? Because you have covered with AWS and cloud some part of it, but I wanted to come back and talk about the tools that generally being used in the industry. And I'm also as an acting CEO of a company called Vitexcel as well. At this point of time, I thought like when the sessions are happening on the cloud and AWS, I felt I should give a talk which talks about the division of tools across the region. I'm like being a cloud computing, learning cloud computing with AWS, and then someone actually have to understand the concept of DevOps, which would also be very important to understand. So I thought this 1 hour I should use this especially for that. And now I'm going to give a little brief about that, the concept of the DevOps very simply, and then I'll explain about the industry, what industry is looking for, what industry actually needs, and what are all different varieties of tools that are existing in the market, right? I'll just give a glimpse of it. That would cover an hour of time. definitely, if we get scope, we'll talk later about it. But I want to give an overview of these tools and of an understanding of these all tools that exist in the market, which are very, very important for someone getting onto cloud computing and AWS. It's very important they understand what all open sources exist in the market and how do people react to it, whether they really consider those tools as a very good tools or they take it light, and how very important those tools are. I'm going to talk about those things, and then immediately after that is then I'll leave 15-20 minutes for the Q&A on that particular area to answer more on it. But I'll quickly share my screen right now. Yeah, please kindly let me know as soon as you're able to see my screen. Madam, can you please confirm me if you can see my screen?
Naveen, sir, no, sir.
No, Naveen? Okay.
Now visible, sir.
Okay, perfect. So what I'm going to talk now is all about the complete roadmap of DevOps. Where exactly what is required. So the structure, this is the general structure that we built in the industry when we do it, when we want to prepare for a product, we're developing something, we create a roadmap. And this is a combination of cloud, your AWS, your GCP, what not combines to it. So everything is part of it, including the infrastructure, the server administration. So I thought I should give you an understanding of overall how the structuring or roadmap is being done, and how do we pick it up, and how do we conclude the overall roadmap to it. But before getting to that, I just wanted to take 2 minutes over here and explain very easily the DevOps. I think most of you would have known, but still I want to just reiterate on that particular one. DevOps. So when you look at it, it's actually two different words. It is development and operations. Together it got combined. Not sure how many of you know, but I will just give a little history about how this name has come into existence also. Earlier days when we started probably our coding and everything, probably like 20 years experience. I know there would be some other people much experience here. When we started at that point of time, it's all waterfall model of software engineering process we had, which is actually very, what do you call, now they call it as lethargical, very huge in terms of looking at the process and everything. At that point of time, in real time in the industry, when a development team and there's separate deployment team at that point of time. Okay. So now also you have it, but now it's automated. So I'll come back to it, how it is. So what used to happen is when a developer does the coding, and there is always a manual intervention that is required for someone to take the build and they have to deploy it into one of the application servers that are there. So when they were doing that part of time, someone has to manually deploy it and look after the process and monitor the deployment process. Okay, that all nothing but the operations team. Okay, and they have to look into that operations of how it is being deployed, and you need to continuously monitor manually, looking at the logs to see if anything breaks up, any reason, or we used to keep some kind of an backend scripts just to let us know or understand that there is some issue that is happening. So which is very difficult process because you need lots of team members, and then development team has no link with operations team at that point of time. So the development team just develop the code, they just give the build to the operations team, and it is their headache after that to do the process. That is how the state used to be, and that's why it's all waterfall model. So when things started moving up, there is something called the agile methodology that is being identified. Of course, we went to say agilized right now, but when an agile is being introduced, they wanted to see that the cycle of a code a development being done in the industry is being cut down. We don't want bigger cycles of development. They wanted only smaller cycles of development that they wanted. That means, what I mean is, they wanted every 15 days something that has been developed to be moving into the actual environment for testing. So is that really possible? But that is what everyone right now in the market do. There's no waterfall model anymore in the market. There's very few companies like TCS, Wipro, Infosys who are working on the older projects. They don't have an option, so they follow the waterfall model. But 90% of the companies follow the agile methodology. Now, the reason is it's always development is going on. It's always development because anything can happen at any moment. Any change can happen at any moment. When this all have come in, still the same methodology has been followed of having the development team and operations team. There is always fight between them. The reason why I'm telling is always operations team never agrees to development team and development team never agrees to operation team, because they give a build and they just give it and they just complain saying that it was working in my local environment or development and it is not working in my operations team will come back and say it's not working in the staging and the UAT or production environments. That is where when agile has come in, that is where this automation process of integrating the development and operations together has got combined. That's where this DevOps has got evolution. And that's where till then no one in the market know that there is something called DevOps. Now you also have SecOps, you have InfoSecOps. So this DevOps has come into existence after Agile has come in, where they understand this manually cannot be achieved when the process is Agile because it's only 15 days cycle. And Agile has 2 weeks of cycle, or max you can combine another 2 weeks of a month's time. So you cannot waste your time in other activities where you give a build, they have team, so much of teams involved. No. That is where they combine the development and operations team together, and that's where they call it as DevOps. There is very close coordination now. Before, as I said, waterfall model, it is manual. Any issue that is being arised in a production or anything in the industry, the biggest problem that everyone we used to face is there's an issue that is been found and then we have to go manually intimate it to the development team. The process cycle is huge, where there is a delay of getting things moved to the product, or reducing the cost was not happening at that point of time. Now, because of DevOps, even that problem will resolve. How? Because of, I'll talk some terms which may not be, but I'll explain them. Because of the automation process that is being involved right now. You must have learned about CloudWatch in the morning session. The CloudWatch on the monitoring systems now helps actually identifying the issues and intimating it to the development team, where immediately code changes will be done and will be part of the automated commits, automated check-in process. Everything is automated. That's where this DevOps is actually being introduced, and it's evolving so big. Now there are huge number of openings that exist in the market today. Someone without a background of programming language, getting a basic programming language can actually be a DevOps engineer. That's how easy it has become, and that's where the cloud computing and all those things that we talk today have become very easy because of this combination, this what do you call these integrations. Everything made life much easier now. Now I will talk about each of these areas, and I'll explain about the continuous integration and continuous deployment process also, how that will go together after the roadmap is being explained. So someone wanted to take a roadmap of being a DevOps engineer, or if we talk, do we really need to be an expert in programming language? And other thing that I wanted to show you here is there are different colors that I've mentioned here. One very important is blue color. Important is yellow. Normal is in light pink color or orange color, which you can call it's normal. So when I show the blue, you should feel that you should think that it is a very important one that I'm talking about. And coming here now, roadmap. Let's start pulling up from learning programming language. So when you start thinking about a programming language here, what are all different programming languages that are there? So every one of us knows that there's this one of the scripting languages. If you know, it is easy for someone to become a DevOps engineer. That's not true. That is one of the prerequisites that someone should know to have a roadmap of DevOps. Someone who are more interested towards working on areas towards cloud computing or AWS. Now, yeah. So now learning. So if you look at it, they mentioned Python as one of the very important area. Sorry, is anyone asking anything?
No, sir, I have muted all the participants because some
Okay.
noises are coming.
Sure. Okay. So there's a Python now. So Python, yes, definitely Python is stronger, but definitely also I would suggest Java is also equally can be in this area, because someone very good at basics of C, okay, is not tough for them to learn Python. But in the market, there's a lot of interpretation that is there. That Python, someone learns Python directly, they can learn. They can learn, but they can never become an expert. But someone who come with a background of C and learn Python, they can become an expert into Python. I'll explain the reasons behind it. When you talk about the object-oriented concepts, right? And when you come around those areas, and also when you talk about the base 32-bit and 64-bit things, I think that is all well been learned in C, Linux, and you need to understand about the runtime and compile time things. So I'm just iterating, but nothing to debate on this thing. But definitely, someone wanted to become an expert in Python. It's good that they have an understanding on C, but someone not just learning C and directly coming to Python, they would be able to do only what is required, but they cannot think out of box. They cannot do a little more advanced things that can be done on Python, because the limitation is that they don't have a background of coming back from C or the object-oriented concept programming. Okay, now coming to the Golang, this is important. The reason why it is becoming, but you don't have to learn everything in the programming languages on the road, DevOps and cloud computing roadmap. You can be strong in one area, or you can be very, I think say very strong. Strong is also a good word to use. Someone learning one scripting language or one programming language is really good to be on the roadmap of DevOps and cloud computing. Golang is something which is really shining up now in the market. There are very less people produced right now in the market on Golang. Most of the experienced people are getting converted to Golang rather than freshers. But freshers are also coming up with Golang these days. And this is also one of the interesting programming language to learn. And this has a great future. Golang is definitely going to have very, very great future. And it can also go along with Python. And of course, Java is evergreen. To be on a separate note, 90% of the companies will have a Java project for sure. That's it. And Ruby, JavaScript and Ruby are again, they're also the scripting languages. And it is good to learn. Even JavaScript, it is okay for DevOps. Either one of them, but preferable is one of the backend technologies, or scripting is what they would say at very high level. So Python or Java, it should be good. That is in terms of the programming. But when it comes to the server administrations, everyone would know about this thing. So there's Linux, Unix, Windows. A very rare combination of Unix and Windows is being found in the industry. Someone who would go with Microsoft .NET would get into Windows, or else 95% of the market would sit on the Linux part of it. Implementations are also being done. Of course, your AWS instance that you create can be created on the Linux instances. That generally happens. Because when you go through the create instance process, it actually asks you whether you wanted to pick a Linux or you wanted to pick up a Windows machine or Unix machine. The 90% of the market runs on Linux because that's easy to do the transactional, that is easy to do the monitoring, and easy to easy to set up because of the Google the cloud. Rather than I would say rather than the different types of cloud platforms that has come into the market. Now we'll keep this. This is a simple thing. I'll not talk in detail about this thing because I am very sure every one of you know. But there are some areas where I want to talk a lot because of the time constraint. Now coming to the servers, these are the real instance servers that we're going to have, right? So when generally a project has been built, a product has been built, the different areas that would be required is the design phase, which would be generally the UI UX part people team would be there who would actually design it. But whereas once you come and be part of the development roles, that are all different again. So before some project has been built, okay, there's a design infrastructure or a DevOps infrastructure or an environment infrastructure that is been built. That is all is this what I'm talking about. What kind of servers would be required for your project to withstand when you're actually about to build it? Of course, you will do lots of changes later because the assumptions of starting the project and the understanding we do on the project and at the final output, there may be a lot of changes that would come into the server setups, instances, and everything. But in general, these are something that would be required in industry before you start a project. These all are ready. You will plan. There will be a lot of teams who would plan all these things. So there's going to be servers that they're talking. So now, when you talk about servers, we have to talk about different servers that generally being used in the market or in the industry. The first thing that everyone should talk is about the web server. Now there's a server, you have a Linux instance that is there, and then you have just an instance, right? But what is it you're going to do after a product is built, or you're writing a code to build something, and then you need to deploy somewhere, and you need a cloud platform where you actually display it over. So to that process, what is actually required is a server which contains and web server being installed into it. Now we're going to see what are all different types. What market is 95% of the market is looking, or what the 30% look into. I'll explain you. Of course, that is what I'm talking about, the blue and yellow. The Apache Nginx, these are the topmost right now in the market on terms of the web servers. Tomcat used to be one of the best before. And IIS is generally when you go with .NET based, and then Jetty. Jetty is known a rare combination of 1% of the project teams use Jetty web server, and then Apache Nginx is the one most of the companies use to have your application being deployed on your web servers. So most of them, they go with either one of them. And coming to the, I'm not going to talk about caching and everything in detail, but I'll explain you what these things are. So when we are building the servers in real time, in general, being a DevOps infrastructure engineer or a DevOps architect, responsibility is to see which server fit-ins and what caching mechanisms and what kind of database is also important for your product or your project to withstand. You need to take decisions around all these areas before you actually start a project or before you start building anything in real time. So to take the decision, that's where the project actually starts with the product owners, technical architects, chief architects, and the DevOps infrastructure architects, who all sit together, come to a conclusions of what exactly would be. But they don't go out of any of these areas because they don't have choice. They have to pick one of this which has been mentioned here. They pick up web server. They need a caching mechanism because caching is really required in the applications. I'm not going to talk about it because it's going to confuse you a lot. But as a structure, I'm just showing you that we need some caching mechanism for the applications that is being built. So we see that there is a caching mechanism being involved, and databases, which I think everyone would be there. So I can talk about it very. Now again, market has again RDBMS, and you have NoSQL databases, distributed wise, key pair wise, and then you have the monolithical. So now, being the microservices architectures and the cloud being in place, definitely if you go with anything like Oracle or anything or any of the RDBMS, they simply start calling it as monolithical approach. They call it the older fashion of developing the applications and cloud, because they would say when you get on a cloud, there is a lot of other approaches that makes your data, that makes your application, that makes your transactions much faster. That's where they call it as, that's where they all talk about now about NoSQL. At the same point of time, I don't deny people not using this because there are already systems that have been built and they're already built with this. And they are going in some production, but they might be already in production, there might be something else, but everything is getting migrated now. If you look at the general tendency in the industry, 60% of the projects right now are migration projects. 20% definitely would be the projects that are already with microservices completely migrated, and 20% are the monolithical and the old kind of an approach that is been still followed would definitely be there. But and the real fact that everyone have to understand, wherever you go, whichever company that you work with, there is always a combination of old, new, and the middle aged technologies always been available in every project. That is the true fact that everyone has to. You're going to fight with the legacy systems, you're going to fight with the latest NoSQL, you're going to do with everything because the project would have been built a way back, which has a combination of it because you started migrating one of the other components, but that would take a couple of years to completely migrate it. So till then, just imagine what would be an effort of an architect or the teams to handle all levels of databases that are required. So they will have NoSQL also. They will also have a SQL database in the instance. They might have other databases also being there. That's where the criticality comes in real time. When you actually compare with just building up a product by yourself, when we are at graduation levels, when we start building, we feel that is what it is. But when you actually come into the industry, right, this is the consequences that we start seeing it. And this you will start seeing it being a fresher. A student comes in also, they'll start seeing it. And there are a lot of interesting things that are happening right now in the market would be a lot of faculty, a lot of professors are migrating into DevOps, cloud computing, and into AI ML with AWS, because you don't need hard coding skills onto it. You need concepts, you need a very good concept understanding, someone actually taking up the concepts and putting it the right way. And because market needs it, there are a lot of openings, because people think that the openings are not there, but that is not true. There are a lot of openings, both at freshers level as well as at experience level. Market is not able to get right resources at right area. So that's what. So that's why it is always a tedious process. And like that's what generally that is what we wanted. Graduation at graduation level, we wanted them to understand is this level of conceptualizing, because they know that it is not that they're just going to handle one page application and one page database. No, there are combinations of databases, there are combination of programming languages that are always involved in every project that is being existing in the real time. I'm just trying to explain, but I thought I should explain this so that it gives understanding of what industry is going to right now. So when you go to the NoSQL, that's what we are talking about. They're like MongoDB, Cassandra, AWS DynamoDB. These are playing very, very, very good role right now in the market. Google Data Store, people or companies who work with Google Cloud Platform, they would actually go with Google Data Store because it would be much easier because it supports at very high level and scalability and portability is really high. But someone going to AWS, they would definitely not go to Google Data Store. They go DynamoDB or they go and they prefer MongoDB or Cassandra. So again, so Cassandra would be something when you query it, for me, it is similar like MySQL. Apache Cassandra will be similar like how you actually query your MySQL database. And MongoDB would not be that because Cassandra is also distributed as well as the keep paid. But for you, MySQL being an open this thing, but you can also query Cassandra at that level. Whereas MongoDB, I know of course DynamoDB has a different way of querying prospects that would be there. And of course, Oracle DB, MySQL, Postgres, they are like have at least similar fashion of using the syntaxes. So if you look at it, we just covered these areas 1, 2, and 4. I think I missed the network security. Okay, but I'm coming back to this networking security, right? So it is very important that students needs to be encouraged and getting into these areas as well, because this is a huge area that is being uncovered as on now in the market. There are a lot of jobs, but what happens is they would not get a right people here. They are actually taking up someone getting trained in Python or Java, or someone has a little understanding on the computer networks. They move them here after. I mean, like basically that is what happens with the people who get to TCS, Ninja, Infosys via Epita or anything. The freshers, they give this package, they train them, and they split the teams into different areas. Unfortunately, the people will feel that they go into these areas, some of them, because they would be actually interested to get into Python or something, but they would end up being here, or they would end up being a tester also, someone who is really good at coding, because companies would not listen to you. They just take the decision based on the criteria that they would feel or the requirements that they have. So better, so that is why we, the suggestion always when I talk to freshers when we hire, or when I hire with and I do the interviews, or when we talk lots of, I think in recent past 2 to 3 years, I would have interviewed more than 400 to 500 faculties who have transitioned from colleges to IT companies. Exceptional people have come in who has solid understanding of the concept, because they're all professors. Definitely they have a good understanding about the concepts, very strong at concepts. And those people shine a lot because they know the concepts, and ultimately they wanted it to be converted actually into the real time is what. And I think that understanding is something which will take for a time. Once they get in, I think once they are it, I think they will be the rock stars of the IT industry. That is what happens. And most of the people started realizing that in IT environments. And we started, like personally, I realized, and my bosses realized, and the company CTOs and CEOs realized about it. At the same point of time, right? So theory with practical combination gets in. Just imagine or like a faculty professors getting a combination of a theory oriented as well as practical oriented. Just imagine how would it actually go with. I think they would be able to spread out their knowledge to thousands and thousands of people, students across whom they are training and whom they are teaching today. That's why. So the network and security, why I'm explaining here is, people think that this area is not the strong area, but trust me, after the COVID, people are realized about the digital platforms, about the online platforms. There is a lot of ethical hacking people that are coming into market now, and that is really good thing that is happening at least now. Because there are a lot of platforms that are online they're not 100% securitized. There is always some gap in it. There is always some breakage in it, because a programming language person would actually be redirected to this. He don't have a vision of what exactly he has to do with network and security. He is being forcefully pushed into it. He has not come with interest over here. And that is where this market is huge. And that is where I think faculties or college HODs or universities, we see whenever we go for campus hearings, we see that we started encouraging that people have to get into these areas also, which is cyber security, right? You know ethical hacking, you do the penetration testing. A person who does penetration testing, he's a security tester. He knows what to test at what and to break the security levels. He knows where to break with DNS. He knows where to break with HTTPS. He knows how the SSL been configured. So these are all very important areas that are being covered. So that's why I'm telling you, DevOps has become so vast. Without all these combinations, it cannot be a DevOps at all. But, and that is what it's been saying, an understanding on any of one of these topics on a particular sector would make them a DevOps experts. That is what I'm trying to conclude. Overall, after this, that is what I'll conclude on. So network and security is very important. So that's why colleges started adding cyber securities. There's cyber security students are getting certified into these areas. There is network security experts you will find ethical hackers, you will find the actual security experts who into, and you will find the network admin guys also, who I think everyone would have to realize, and even including me or anyone, that without a networking guy or a network and security guy, I think there is no IT company exists, or there's no project that would start at all. Because if there is no network and security being implemented, what is that we do? We don't have to do anything. So there are certain things that are very important that everyone at graduation level should understand before they get to IT, and everyone requires this level of focus. And now, fifth point, as I spoke about the servers, I want to talk about infrastructure as a code. I'll go very quick on these areas because these are a lot to learn on these areas. But the reason I'm telling you, so that you have everyone will get an understanding and they can start figuring out an options to learn these things, which would actually help also to in return to go and teach back the students on how these are very helpful to students as well as the faculty as well as the trainers in the market. Now, infrastructure as a code, what exactly I'm going to talk here is about the configuration managements, different kinds of containers, and how this container orchestrations will be done, and how this provisioning is being done. So these are all things so technology is emerging. So initially when we started, right, so we know that there's a programming, we know that servers are there, that servers are different kinds of servers are there, and we know that there are different kinds of web servers. Web servers are keep getting added to it, and these are all changing because there's a lot of cloud. That's where these infrastructure as a code has come into picture. All these that you will start seeing are all which would have come in recent past only. It is not there. If 10 years back, if you start looking at these things, I don't think so. They would have been evolved. They would have evolved, but there would have been nothing being done using these things. So quickly, I'll explain each one of them very quickly. So configuration management, Ansible. Ansible is such kind of an area that is very important for someone on the DevOps and cloud computing is different reasons again here. So I'll also give an example of where the situation would have failed in the current industry with having the implementations of configuration management and how you actually be out of it also. Ansible, I think most of you people would have known Ansible is a Red Hat Ansible, they call it now because it's been purchased. Okay. What exactly Ansible is used for? To simplify the IT process that we do above four points, to make that process everything easy, automate with the cloud provisioning that you get it. Okay, we can start using Ansible can help you to make it very easy. That's why it is configuration management tool. It is mainly being used as DevOps tool, and it can actually perform lots of tasks. Things like, I'll just give a simple, like it, time consuming is one, complex is one, repetitive is one. I'll give one of the examples which happened in 2017. Okay, in USA, one of the major banks, they had an implementation that they have to do, and normally bank applications are very critical applications where you cannot take down of the application. You take it down also. The hardly time that is being provided to a DevOps engineer and architect would be 15 to 20 minutes. That means there is a lot of effort that is have to be kept before we agree and we do the transition from the UAT environment to production. UAT is nothing but the user acceptance test environment to production environment. Okay. When you have to do the transition, you have only 15 minutes. But because of different reasons, when a user acceptance test is been done, and the testing team would have tested it and everything would have been really went well. And this is a real thing which had happened. I'm just not telling any example. It's a real example. So 2017, as I said, so next day, they have finished all their process as they planned in the weekend. Monday morning, by the time they came to office, they found that there is a issue because of which the transactions are started failing in the bank transactions, and the monies are getting reverted back to the accounts that the transactions are being done through. And it is one of the biggest failures of history in the IT industry itself. And I'll send the link to this to circulate it around. You can actually read it across. Now, because of this configuration management tool, they could able to save millions of dollars, but by that time itself they have lost some money. What they have done, I'll just explain. Ansible, Puppet, Chef. These are all such kind of configuration management tools which can take you back to the history and revision back to the version of the old that is existing. And normally what happens is, even you have to do that at certain situations, it takes minimum 3 hours for you to revert it back. That is what we call it as disaster recovery in IT world. So this is a disaster recovery plan, but this they have to do it upfront on there. Ansible has one of the features and configuration management which can revert back to your older version in less than 60 minutes. 60 minutes, don't think it's very high time. Situations of this, having a configuration and reverting it back completely automated. You on one click, it will auto revert back you to the older version in a 1 hour's time. Just imagine if this is an older system methodology, and you don't have a right DevOps tool, configuration management tool existing, that bank would have been closed, been sued by lots of people. That's where this configuration management helps as one of the proper, what do you call, one of the important tools in helping you to revert back to your older version history of the necessity versions using Ansible tool. So it will revert it back completely, so that because the older version is already a production version, you revert it back, and that's how they've resolved this particular issues. And those are critical. These are critical. So someone who doesn't have an understanding of Ansible at that point of time would have been really in a problem. So they would see an expert who would do it and then revert it back. And that's how the configuration tools are very important in IT industry and DevOps. It helps you at right situation and right manner way. Now I'll talk about the containers. Most of you people must have heard about the Docker. There is also something I was mentioning here about LXC and Akiti. Do not worry much about that right now, because I'm not talking about everything because of the time constraint. I'm going to talk only about the things which are very important at this point of time. Now coming to the Docker, right? I want to talk a little about this. I'll take 2 minutes here. So working with containers, whenever anyone, I think the reasons why we go with containers, first of all, okay, is something everyone have to understand it in terms of knowing and examples, or majorly to talk about a Docker. I'll give one of the examples here again. So let me pick up some very good examples. But before giving an example, I'll also explain when someone wanted to go to containers and using a Docker, it is nothing but they wanted to make their life much easier on how to set up, deploy, and run apps at a scale by containerizing them. So that is why. So Dockers are majorly used for that purpose. So let's say like you have a Docker, okay? I'll give one example of a real-time example here also. Let's say there is an application that is being built on 4 different versions. Let's say like version 1, version 2, version 3, and version 4. Now what I am as a DevOps architect or as DevOps engineer, I've been instructed that this is what has to be deployed using container Docker, because the reason why we're taking Docker there is because these all applications are built with same programming language, but at one level, at one version, it is still with older version of Java or Python that is being used. What happens is it doesn't allow you to install it at all on the Docker. The reason is because it has the same, it has a different versions of applications that is being there. So what people do here is, that's why they can have 3 different boxes, as I said, can be deployed, and then they'll have the 4th one also deployed. Here, the advantage of having Docker is not only to set up, run, and easily, but also you have this advantage where if your versions of your product that has been built on different programming language, same programming language, but with an older and newer versions, you can actually take an help of a Docker to have that being there, because you wanted the older installation also, older application also to be there, as well as the new one that is being built also is required over there. So this is what people have. So we would never imagine something like that. You have different versions of the same product being built, right? So that's how this Docker and everything is coming and actually started helping us. And the other things, I think everyone must have known, this is an open platform, basically where you can actually ship and run applications, as I said. It enables you to also deploy applications separately in your infrastructure, where you can deliver software very, very, very quickly. That's why that's why they started having Docker. I'm not talking in detail about how this Docker and everything, but that's how Docker has come in. So you can have different versions being deployed by taking help from Docker. Now, container orchestration. Now, I'll talk a little here also about the container orchestrations, but I'll not try explaining in detail about Kubernetes because those are all very advanced topics. At the same time, I will just give an intro about the container orchestration. Why this container orchestration? Why do you need this? Okay, and why do you actually require to automate it? So container orchestration is such a process. I can call it. You cannot call it as process, but you can call it a way that used to automation most of the operational efforts are required to run containerized workloads and services. What does this mean is, I'll explain it in a much clearer way. Why would you actually need a container orchestration? Okay. What it will do is when you actually go in real time, you have to do the deployments very heavily. You have to actually do the applications at much higher level. Container orchestration can be used in any environment which uses container. What I mean is everything is interlinked. Configuration management, you have Ansible that I'm talking about. Container, there's a Docker. When you have a Docker as a container, that is where you can actually also go and do container orchestration. You can do and you need not have to do also, but it depends on project to project. Certain project you don't need container orchestration, certain product development, certain service applications that you build requires container orchestrations. So when an environment where you use a container can actually use this container orchestrations. And now what container orchestration will do is it can help you to deploy the same application, different environments without a need of redesigning it. So these all concepts have come in when microservices architectures have come in. Because generally before when you develop the services, the RESTful services and everything, you have everything in the same application. But now the container orchestration, after Docker container, you can actually deploy each API service into a different container. And that for container, you can do container orchestrations. Like you take the microservices in containers, make it easier to orchestrate. That is nothing but you are giving all facilities to that particular containers by providing security, storage, and networking. It gives you orchestration to the services. It includes storage, networking, and security also. And that's where people will go for container, and as soon as they go to container at bigger projects, they go and start using container orchestrations. And one of the top container orchestration that you go and look at right now is a Kubernetes. It's ruling the world like anything. Docker Swarm is there, OpenShift is there. OpenShift is also being used. The next top in the market is OpenShift, which also does the same thing. And now infrastructure provisioning, I think I have another 20 minutes. I'll try to cover it much faster now, or else I'll take another 15 minutes if they allow me to do that. Infrastructure provisioning. So infrastructure as code, we are telling it. So you have a code, and through that code, using a configuration management or Ansible or kind of you use Puppet or Ansible or Chef kind of a tools, you see that it is being taken up, being executed, being worked around. With help of containers, you are actually differentiating it as a separate components, and you do orchestrations to it using two things like Kubernetes. And for all these things, right, there's an infrastructure provisioning that would be required. There are 4 players close. They're like which generally provisioning it. One with your AWS Cloud Formation, Microsoft Azure template, and then Google with Google Deployment Manager, and then you also have Terraform. And Terraform is ruling in this place. And same way, AWS Cloud Formation also has the huge market in infrastructure provisioning. Most of the projects that are in AWS, they actually go with Terraform and AWS without even thinking about it. Now, if you look at it, right, we've been building the DevOps. So we're building the complete infrastructure. Now, after the infrastructure is provisioning, everything is done. You have decided what servers are required. You decided what programming language is required. You have set up all the protocols, DNS, everything. You have kept the servers ready. You have the databases ready. You have an infrastructure being kept ready. What kind of tools I need to use to make my code run automated process is being designed. Now it comes after this, it comes is the continuous integration and continuous deployments. In that particular one, the one that is ruling is the Jenkins. Jenkins is actually, if you see in the middle, this always stands in the middle. The reason is because this is the middleware component you can call. It is not a middleware, but I'm just giving you an example. This Jenkins is the main part in integrating the development team and operations team. So now if you understand, if I'm making sense to you all, how this dev and operations have combined is there's a tool, there's an operations that are built in is called continuous integration and continuous deployment, where Jenkins is one such tool which has combined the development and the operations teams together using Jenkins as a tool. That's how it has come in. There are also other players that are there in the market. Or TeamCity, Circle CI, you have Travis CI, you have AWS Code Pipeline, you have Google Cloud Build. So using Jenkins is actually you can do the builds, which is just when a project has been built, right? You generally write a code, you now have to build a WAR file. Jenkins is one such which helps you to build it and takes with the operations of automation process of continuous integration and deployment. It uses this tools like Ansible, Puppet, Chef. It actually goes from here to here. It finishes off all this process, which is on the left side. It finishes of this, but this integration layer will combine this and this together. If you look at here, this is combined, this will get combined to this. Without this, this cannot be combined. This cannot be again a DevOps. It's again a development team separate with the operations team separate. But this CI/CD, from the time these terms have come into picture, in the tool existence of Jenkins have been there, which helps you to build your components, right? Using if someone actually goes and completely uses AWS as a platform, they also use AWS Code Pipeline to build it. Jenkins can also similarly they work, but it's all open source. Jenkins is open source, but AWS Code Pipeline is a service component which has been used. Google has Google Cloud Build. Azure also has one of them. I don't remember the name of it exactly, but Azure also has the same kind of a tool by itself, which can be used when you actually use only the Azure platform as a cloud platform. Now, when you do this continuous integration using this Jenkins, right, that means a simple concept of combination here. GitHub, okay, student has account with GitHub. They go does their coding using the GitHub commands, they do the code commits. That code commits, actually what it should take, code commits will be moved to this, it uses something like the middle layer, like I would call this, Jenkins would take it and then it would actually go and give it to Ansible configuration management for you to build it and store the versions. And then if you have a Docker configuration, everything will be configured in the same thing, because this is all, when we code it, we code and we configure it accordingly, that it goes to this, and this Ansible responsibility to see that the container Docker has been picked up and using the Docker has been taken care and the deployments is done. Now, when it is helping you to build all these things, now using build, you have to deploy your component or your application or your services somewhere. Now, what is that you're going to go and deploy? That's where the cloud is coming in, right? Where do you deploy it? And now you have everything now. You have done the coding, you have the infrastructure, you have built it, you have tools that will actually help you building it and storing your builds. And you have an orchestration that has been built in the infrastructure, but where do you actually go and deploy it, and where do you actually launch it, and where do you actually launch? Where do you actually keeping it? In-prem? No. That's when you're going and picking here on option monitoring and logging. I'll come to it later because I wanted to finish up this process where you pick an option of one of the cloud. Like there is AWS, you have Azure in the market, which is Microsoft Azure, GCP, Google Cloud Platform, you have OpenStack, you have All Cloud, and you have IBM Bluemix. I'll also tell an interesting story here because I have another 12 minutes, but I'll tell you Bluemix, IBM Bluemix is the first cloud platform that is actually has been coming to market, but they couldn't able to prove, and they are sitting at the last in the market in terms of the cloud. IBM Cloud is always at the last. No one in the market would. It's also expensive and no one would go. But this is the first one that has been built in the market. And then Azure was built, but in the parallel at the time AWS has come in and huge amount of components and services have been built here. And every time you go and look at it, there is a different component service that has been built in AWS. That's why it has become very, most of the market cloud ratio or revenue is with AWS. The next is with Microsoft and GCP. GCP and Microsoft are running in the same range. OpenStack, these three are being used by very few people. IBM also uses AWS. They use GCP and they also use Bluemix for the projects where they feel they can fit in. They actually use IBM Bluemix for themselves. So for building an infrastructure, it is all about the different kinds of tools, their combinations, their necessary integrations as required. Now I'll just explain about the monitoring and logging. Now everything has been built and you have deployed and it is running on a cloud environment. There's a monitoring and logging mechanism that would be required. And that's where there are a lot of tools which have become very famous in the market. You might be thinking why CloudWatch is not there here, because there's a lot of less number of people uses CloudWatch. There's something called Zabbix. There is Grafana, Datadog, New Relic, and CheckMK. The highest number of users that use is either Grafana or they go to Prometheus or Zabbix. And when you go to the logging, I'll talk about this in 1 minute, but I missed something here in monitoring. So you would have learned about CloudWatch. CloudWatch is also one of the monitoring tools. But AWS by themselves doesn't use CloudWatch a lot. There are some disadvantages that they have. There are some areas where they would not be able to figure out what exactly is happening with the production issue when it comes up. That's why there are other market players like Grafana, Prometheus, and Zabbix in the market, which actually have built a very stronger monitoring tools, which helps you monitor very properly. It's an auto monitoring, right? Definitely they monitor because everything is configured. You get alerts and notifications whenever there is something having an issue. Logging mechanism is again, so this logging is generally nothing but when you write a code, we write logs that actually wanted to come into the, that is what we call logging mechanism. Definitely we wanted those logs to be properly being monitored, properly being looked into. The reason is because you might have to go and debug a issue which might have errors 3-4 days back, which you realize that after 3 days you might have to do that. For that monitoring and logging monitoring, there are 3 things which are very important in market are ELK, Greylog, and Splunk. ELK is one of the topmost and high sharing, like high revenue generating for most of the companies use ELK and Splunk. Splunk is pretty expensive, but at the same point of time, markets use it. That's why you see monitoring tools, right? Where everything is very important in important categories because they can go with any of them. So because everything is equally equally strong. But Grafana and all those things which you see it in blue one, they have a little more capabilities than what the Datadog New Relic has. Of course, ELK is very high, very good in terms of querying on the logging because Splunk is also, I think most of you would have known, there are also certifications in Splunk. There are also Splunk people just do only that. Their work is only on the Splunk because they can query, you can query on a Splunk to find out a log on a certain date. It all can be possible on Splunk, ELK, and Greylog. But ELK is more extensive and easy to use and easy to query on it. Now, as I've explained to you, if you all look at it, right, this all is a combination of your continuous integration, continuous development. That means from taking from development till operations and letting everything know to the developer team, it's all a continuous process. So you don't have to break here. But whereas waterfall model, the monitoring and logging has been the toughest area for them because they have to manually watch it, figure out if the issue is there, and then they have to report and go back to development and report it back. But after the DevOps and the automation and CI/CD has come in, this monitoring and logging mechanism has a notifications that directly sends out to the development team where the action can be immediately performed. They do the code immediately. They put it, they do the commit. It again comes to CI/CD. Jenkins moves to Ansible container. This is called continuous integration and continuous deployments. So your process is number 8. 8 is like continuous, right? So your process is always like write the code, check out the code, write the code, build the code, test the code, and build and deploy it using the configuration management tools, and then integrate, build it within, integrate with Jenkins, and then have it on one of the cloud being deployed and have a monitoring and logging that has been configured. Any issues that comes up, immediately monitor and logging is already will be configured with the required necessity configurations, okay, which will immediately give an alert back to the development team saying that there is a production issue that is being identified with the logs that it identifies will be automatically being given to the development team without wasting the time. The developer will start working on the project on the bug and the fix, and they do the code commits immediately. The configuration management, the change management, everything would go, and the deployment will be released to production immediately the next day based on the approvals that they get it. The only thing that will hold is that probably they have to do, but everything is automated. There is no manual intervention would be required, but this is all being configured and kept as a process by A DevOps engineer and architect who designs it will actually configure this automatic process, and they'll keep everything ready so that the life of a developer will become very easy. So that is what it is all about. And that's how the overall process would cover into. That's why I tried covering as much as I can in very shorter and manner. That's how a cloud is important. Cloud computing as a combination of AWS. It can be cloud, can be any platform. That can be AWS, Azure, or you go and pick GCP. But the overall combination is same. Whether you take an AWS as an option, you take Google as an option, or you take an Azure, Microsoft as an option, the roadmap would never change because these are all open source tools. And if you look at Code Pipeline, Google Code, those are the components that have been built by AWS and Google people. And rest other things are like you have open sources that can be used where you can actually finish off your job by open sources. Jenkins is also an open source. Someone doesn't not going with AWS as a platform on a whole, they can actually go and start using Jenkins as an open source. They don't, companies doesn't try to spend money on this thing. That's why they go and use the open source components over here, and they configure everything so that there is no delay in development. There is no development delay in deployments. Everything is automated now. That's how the technologies have been. And trust me, all these AWS, Azure, GCP cloud servers, they are not in the cloud. That doesn't mean that they are really on this cloud. They are being, the centers, data centers are sitting inside the seas right now. Most of the data centers with high potential are all being in the data centers which are deployed in the sea. And most of you must have read it, so but I'm just reiterating it. So the Lord, now everything is in the sea. They have the data centers in the sea because they don't want to waste the infrastructure in there. That's why they went and they started putting it up there because they're saving the space. They're also doing a lot of other stuff that is related to them has been covered around. Now I'll leave it to Q&A. I know I took all 1 hour 15 minutes explaining it. Yeah, but yeah, 15 minutes on any questions that I or anything that I told wouldn't have been understand. So I'll try to reiterate it. Please. Naveen.
Yes, sir. Sir?
Yeah. So questions, I am Q&A. Anything required.
Okay, sir. So participants, if you have any query, any doubt regarding the entire concept which answer has demonstrated, I think within the single slide, sir has incorporated the entire world of DevOps as well as cloud. So I think there would be no any application left except all the applications which is mentioned in that slide. Even though if you have any doubt or any query, feel free to ask to sir, or you can use the query by writing down in the chat box also.
I'm happy to answer anything that even the question is irrelevant. I'll be happy to answer it. Anything that you feel that I can answer it. The reason I kept everything in one slide is basically for you just to give a picture of how the industry is actually and how these all people are putting. I mean, this is something which we have to let students inform, and students should know about this. That this is how it is. All the system is all around like this.
But let me say, sir, but it definitely anyone can assume that definitely it is the last session, but it has incorporated each and everything which are said or which are not said. Everything in this session has the entire concept.
Yeah, and kindly please share them the recording if they need it, so they can actually revisit and listen to it.
Yeah, we are sharing each and every session's recording, sir.
Yeah, yeah.
The participants again.
Charan Garu.
Yes, sir.
Good afternoon, Master. This is Dr. Isaac from KL
Yes, sir.
University.
Please, sir. Please, sir.
After going through your slide, actually, it is really very interesting to know about this. I am from a different background, that is from mechanical engineering department.
Okay.
I really excited to know about all these technologies which are upcoming in this area. But what would be your suggestion to a novice man if he wants to enter into this area? Does he or she will have any chance at all? If chance is there, actually from where he can start? Please.
Okay. That's a real good question, sir. I think that would be for most of the people who come from the core branches. For DevOps, as I said, sir, there's no background of coding that would be required, but a concept-wise, a little understanding of prerequisite of any one scripting language is little important for them to understand, because at certain points of time, when someone being at architect level or being a DevOps engineer, they would not even require that Python scripting language, but that is required only just to have a little level of configurations that is required to do that is required. So someone wanted to start being from the mechanical background or anything, the suggestion is, I don't even say that you have to go back to it. You can directly start with all these tools one after the other. The first tools that you actually have to start looking is the DevOps tools, which I was mentioning it out here. You should start with those tools, understanding those tools, and how to implement those tools. If you know it, you're done. And those are all configurations. You don't have to do any coding of these tools. And directly you can jump in and start looking into the, but someone don't be as a layman on the Linux. At least someone should know those basic commands at Linux on the command prompt, which generally we do it. If someone at least do that, all these learning tools is an easier job, sir. Very easy thing. That's why DevOps, lots of people from different backgrounds get succeeded in this area, because it's all about tools and configurations. You're good at tools, you know what tool does what, your job is done. I think you should start from tools that are required for DevOps. Yeah.
No, times. The approximate time span, how much it may take for a novice man, Master?
Oh, 3 months. Okay.
Okay.
Not more than that.
Okay. Thank you, Master.
Any other participants? If you wish to talk to sir regarding anything, regarding your career pathway or anything else. If not, then from 3:30 valedictory session will be started. And Charan sir,
yeah, I'll be there. Yeah, I'll just keep on mute. I'll take a break, have some glass of coffee or something, and I'll come back.
So everyone, it's a virtual tea break for all of us. We are again going to join from 3:30.
Sure.
For a valedictory session. Okay.
Sure.
Then thereafter our examination will be conducted. Okay.
Okay. Yeah.
So we hope we are again meeting at sharp 3:30.
Done. Done. Sure, Naveen.
Yes. Sir, Sharan sir.
Yes, sir. Tell me, sir.
Still your screen is shared, sir.
Oh, okay.
Okay, sir.
I'll stop it 1 second. Oh, it is still shared? Okay.
Yes, sir. Now
Yeah.
okay, sir. Now
I did that. I did. Yeah.
Good afternoon, everyone. First and foremost, I would like to thank KLEF for giving courage and wisdom to organize this short-term training program, Practicing Cloud Computing with AWS, sponsored by All India Council for Technical Education, AICTE. It has been a pleasure to host this event for this week. The participants are highly enthusiastic and responsive. I am thankful to all participants and to be part of this learning journey. And we have been fortunate to have eminent resource persons from academia and industry. I am sure that the participants were benefited by attending this short-term training program. Now I request Charan sir speak some words about this program. Charan sir. Charan sir.
Yeah, I'm there, madam.
Charan sir, I request speak some words about this program, sir.
Oh, okay. I just came back to the, okay. Yeah, I'll do that. Actually, thank you for giving it. I think I would like to, it's a good afternoon for everyone. And definitely it is a good initiative that definitely KL has done along with AICT. And thank you for organizing this kind of programs. And it would be always very good for industry as well as it's good connect between industry and academic world. And this kind of initiatives would be required a lot because we are there to explain what exactly is happening in the industry, and and it is very important that academic world also understands at the industry level, and we also wanted to understand what is happening at academic level. And we even I think in industry level we also have to think something that there should be always something that or even for professors we have to listen to it because we want to listen what academic world also says about uh, what exactly would be required for the students to get benefited out of the industry. I think thanks for giving this opportunity to me. I think Naveen was there, and then also to Amarendra Garu. So thanks for giving this opportunity to present few of my time in taking up this activity, and then the sessions before was also very excellent being done. I've been looking at those videos, and definitely a very, very good initiative. And thank you for inviting me again and being part of this one. I'm so happy for this. Thank you.
Thank you, sir. Thank you, Charan sir. Now I request a few participants to give their valuable views and suggestions regarding this STTP. Now I request Dr. P. Ishak Prasad sir, please say some words about this.
Good afternoon, madam.
Afternoon, sir.
My voice is audible to you, madam, because your voice is very low. I could not hear you.
Yes, sir. Your voice is audible.
Okay, thank you, madam. this is really, as Charan sir was telling a minute before, a very good program indeed. When I saw the brochure that was circulated by the Department of CSIT regarding this program, being a mechanical engineering department professor, I thought a while, since I have a little bit interest in this computer science area also, I thought for some time and I have chosen this opportunity. In fact, the Department of CSIT is conducting this program in 3 phases, and this is the first phase. So I thought, let me join the program in the first phase itself, and let me see what is this web servers, cloud computing, and what is happening actually in the industry. When I was doing my BTech, we used to have Fortran programming, that is Fortran 4 programming, computer science subject, and that we used to study. And after that, when I learned this C programming, and when I taught this data structures through C programming and OOPS programming through C++, I had been into a little bit of these computer science subjects. And I'm very fond of this Ubuntu Linux operating system. And sometimes I used to compare with what little knowledge I have in these operating systems between Windows and as well as Ubuntu. And I felt like there is quite similarities between these two. But what I really like is the disk operating system, wherein which is totally CLI, command line interface. So with this intention, I thought to join this program, and I have registered. And to my surprise, I have to appreciate really the efforts put by the entire department, right from the HOD to all, to make this a success. And the day one itself, not the day one, the 0th day, the day before day one, you were very excited, and on Independence Day, I think so, yeah, on 15th August itself, you have been started motivating all the participants through your WhatsApp messages that tomorrow is our first session is going to start, and you have made all the participants to become aware of it. I felt somewhat why one day before itself these people have started, but at that point of time, I was not knowing that this program is this much big, great, successful program. And let me say that in a cricket match, if the match will be won by hitting a sixer for the last ball, then that will give us very excitement. Similarly, I felt the concluding lecture given by Charan sir is something like that. It was a sixer for the last ball, wherein he has given the total picture in the industry, what is happening, how it is happening, what is this cloud, so which made us not to feel that this is something has come from the moon. So we can think about it, we can enter into it, and we can learn something into it. And the way how he made the things clear to a non-computer science background faculty also, that it is not that much important or essential to have a very good computing skills to enter into this field, but conceptual skills are ruling the government, ruling this environment of this total cloud computing and web apps, this total application developments environment. So which really caught my sight, and I hope that the people who have participated here might got awareness about this point, and they will really look into these concepts, wherein they will sit at the top position before anything comes into reality and into application. They have to design the things first, means they have to visualize that what is going to happen in future, how it should happen. They are the architects, they have to plan it very critically, very perfectly. Then only the applications which they exist in reality, they will run in the similar kind of way without any flaws, and that will fetch the benefits to the organization. This is what I have understood. And during these 5 days of course, all the speakers, right from Srinivas Garu to Stephen, and all they have done the justification to the title, short-term training program. In fact, at the end, I'm feeling that it is really a very short And in fact, it is really a training, hands-on training have been given by introducing all these facilities. Let me not use the facilities, services given in the AWS, Amazon Web Server, starting from EC2 to RDS, SSS, everything. And we actually built our own instances. We have built our own buckets in storing the data, and we have uploaded the files. We have created our own web pages, and we have made it public, and the link, web link also have been given to others. They have tested whether it is working or not, and when they have tested, it is working. So which has given us really excitement, and it is making me to really jump into deep and learn these development apps. So in this connection, I would like to really appreciate the entire, though the department is newly formed department, has done a very good, extraordinary, exemplary job in this direction. And I feel I have gained a lot of knowledge in this area, being a non-computer science engineering branch man. This is what is my feeling about the entire program. I really thank from the bottom of my heart for each and everyone who belongs to this program for sharing the knowledge and making this program a success. Thanks for giving me this opportunity. Thank you.
Thank you, sir. Thank you, Professor. Now I request Dr. N. Shanti ma'am. Dr. N. Shanti ma'am, please.
Yes. Am I audible now?
Yes, ma'am, audible.
Yeah, thank you. Very warm good afternoon to one and all present here. I am Dr. Shanti, Professor and Head of Computer Science and Engineering Department of Kongu Engineering College, Erode, Tamil Nadu. First, let me thank the organizers for giving me this opportunity to give my feedback on this AICTE sponsored short-term training program on practicing cloud computing with AWS. Really, all these sessions were very, very useful. I would say all the topics and the speakers are really excellent, starting from day 1 till day 6, like what Isaac sir told previously. All these sessions were really very useful and helpful. Particularly Stephen sir, if you take all trainings he has given from every day from second session till fourth session, untiringly he has given practical hands-on sessions on working with this AWS. Similarly, all lecture series every day, first session as given by eminent speakers. Even some speakers, they have asked us to introduce, and based on the expectations given by the participants, they have addressed this program. Really, I would like to thank all the organizers of CSIT department and CSE of KL University for making this program a very, very useful and wonderful session. Thank you once again for giving me this opportunity. Thank you.
Thank you, ma'am. Thank you so much. Now I request Aruna Kumari ma'am, please speak some words about the program, ma'am.
Yeah. Am I audible, ma'am?
Yes, ma'am, audible.
Yeah. Good afternoon, everyone. I'm thankful for giving me this opportunity to share my views on the short-term training program on practicing cloud computing with AWS. To start with, from day 1, the sessions by Sanjay Kumar Panda sir were really very interesting, and he made the day that the second, I think it is the second day he has given a talk for to us on the past, present and future of cloud computing. And he has given insights in such a way that he has talked about many research topics, taking few case studies and making them very clear and giving the ideas, research ideas for the new people. And I really gained a lot from his session, where it is directly pointing out towards my area. And coming to the Srinivas Rao sir sessions, he made, though in 1 or 2 hours, he made it very practical, and he made everything very clear. The sessions by him also very, very wonderful. And to talk about the sessions of Stephen sir, I really wondered how he is able to maintain that pinpoint punctuality. if he's saying that today, okay, we will be meeting after tea break, it will be 3:15. He has maintained that punctuality and pace, and he has completed his sessions from the point how he thought of ending it. Because he used to say in the beginning of the session, these are the topics we are going to complete in this session, and we used to do them by the end of the session. And his energy levels are in such a way that from the first second till the last second, he maintained the same pace. And I really wonder how he made it. And it is very interesting to follow him. And coming to the sessions also, he made them very, very clear. Till now, I have attended a few workshops related on the same field, cloud computing with AWS. And in that workshops, I'm able to gain knowledge like how to create instances and how to move them from and how to shut down. This is the knowledge we are having. But each and every step, for creating an instance in EC2, we have to follow 6 steps. Each and every step he has explained in such a way that everything is very clear and very confident. And now I can wholeheartedly say that most of the participants who are in this field are now capable of handling the sessions to their students in a very confident way. And coming to the sessions by Sri Charan sir today, he has given the overall view of AWS by giving the insights to the developers using DevOps. So to say that this short-term training program is very fruitful and very beneficial to the participants. And not but the least to say about the organizers, they have maintained continuous communication with the participants, making them aware of what is going to happen the very next moment. And also by the end of the day, they have shared the materials which helped us, which some of the concepts which we are unable to do at the time of the course because of the net issues, because creating an instance in AWS, it used to take some time. But we are able to complete them in the evening following the videos. So I thank the organizers who have made this possible to follow the next day sessions also. This made it possible. To end it, I thank each and everyone who are directly and indirectly involved in making this course beneficial to all the participants. Thank you.
Thank you, ma'am. Thank you for yours. Now I request Saranya, ma'am, to speak some words about the program. Saranya, ma'am, please. Saranya, ma'am, your voice is not audible, ma'am.
In this particular STTP, especially the storage types, instances, and really I would like to say that case studies was very much practical. So my favorite was Stevens' session because it really helped me a lot. And thanks for the opportunity. Once again,
Thank you, ma'am. Now I request Ravi Kumar, sir, please speak some words about the program. Ravi Kumar, sir. I think he is not available here. Now I request Steven, sir, please say some words about the program, sir.
Uh, yes, hello everyone. It's a marvelous program.
Yeah, good evening.
So, yes, good afternoon, everyone. Uh, it's a marvelous program. The syllabus, also, the curriculum is good, it's challenging, but it's and very practical. So, also, we covered a lot as I talked to the participants in the last session today. We covered a lot, not only the core services in AWS, but also quite a few of what I like to call the extended services that you use to provide functionality to the core services. We've done that, and the syllabus, the curriculum I was given was very, it did not, I do not like to ignore the theoretical foundation of any training, any technology. And especially with AWS, if you understand, if you have a conceptual understanding of the various services and the AWS infrastructure, that is when you will be most effective, as I explained to everyone. That is when you will be most effective in actually implementing those services. So we focused on that as well. But by and large, it was, I tried to make it as hands-on as possible. And I think a lot of people have benefited from that. Also, I also encouraged everybody in the last session that we have done so much in this short span of time. Why not take it a little bit further? By now, you all can consider yourself not only simple practitioners who can pass the AWS certified practitioners exam, you all have achieved quite a bit that you all can now think seriously about going for the AWS certified developer exam. And another thing, which is you all might be surprised or it might be hard to believe, a few of the topics were actually from the curriculum that belongs to the AWS certified architect exam, which we did cover. Complex stuff. And people were very, I thank everybody and all the participants because they showed up every day, they showed up on time, and start to finish, nobody left. And they were, it seems, very involved, very engaged with the program. So without their participation and with their eager participation, they are the ones who've actually made this program a success because they could receive it and they could use it. So yes, thank you very much. And this was a great program. I was very happy. I am very happy to have been a part of it. Thank you all.
Thank you, sir. I am very much thankful to Dr. K. Amarendra, sir, for always giving support for organizing this training program. It could not have been possible to organize this without his valuable suggestion time to time. Now I request the coordinator, Dr. K. Amarendra, sir, HOD CSIT, to address the gathering, sir. Yes, sir, audible, but voice is breaking, sir.
Okay. So, good evening, everyone. First of all, I thank the team members who
Amarendra, sir, sorry, sir, your voice is breaking, sir. Sir, it is not audible, sir.
I'm moving my just 1 minute. Give 1 minute. I'm moving.
Okay, sir. Okay.
Is it audible?
Yes, sir, audible.
Thank you. I'm speaking in my friend's Naveen Kumar. 1 minute, echo is coming. Just please wait. Right. First of all, I thank all the people who are behind the screen to make this event a grand success by working day and night, 24 hours a day for these 6 days. I thank each and everyone for their contribution. And I also thank all the participants and especially the people who are from non-CSE background. So the people who spoke just mechanical, Dr. Associate Prasad, Isaac Prasad, Associate Dean, IQAC. And I thank all the participants who are from non-CSE background since it proves that they had interest to learn something which is okay. It proves that they had interest to learn something which is not their core area. Just remember that even for us also, if we doesn't belong to any core branch, we never see any interest in that. But attending completely with full interest is really a great thing. And coming to our trainers, Mr. Charan, Stevens, and Sukesh. I thank all the three, and I received a number of messages. I received in the form of feedback, and I also received in the form of personal WhatsApp messages where they clearly informed that it is really a great session and they learned a lot. Actually, we are running short of time. At first, we thought of running a 50-hour program, 50. Later, AACT informed it must be of maximum 36. So we shortened to 36. But again, there are some limitations where we need to include various guest lectures, especially NEP, National Education Policy 2020. AICTE informed that it is a mandate that every FDP or STTP must have a session on NEP 2020. It is a mandatory part, and we thank all the guests and special guest who delivered on NEP, Dr. E. Srinivas Reddy sir, and especially Dr. G. Srinivas Rao from USA, where he used to take class from 9 a.m. to 11 a.m. At the same time, 9 p.m. to 11 p.m. from his side. And Sanjay Kumar Panda sir, and today's special guest, Dr. Mukesh Kumar. So we thank each and everyone. And at last, I thank all the participants. And I want to inform one thing that actually, since we never informed anything about the university, our university, KL University, CSC and CSIT departments. In CSC, we had 300 faculty members in that branch, out of which 150 are doctorates. So I want to convey these things that because we had many internal specialists to conduct this event, but we had some restrictions. And what we thought is from the next phases, phase 2, 3, and 4, we will include sessions of our university also, along with NITs, IITs, and international speakers. Internally, at the beginning, what we thought is, let us give publicity for this event, but without any publicity, only with a single mail, only with a one mail, we had 400 participants in all 4 phases. First phase completed immediately, and the second phase already it was scheduled from 30th August. Those seats are also completed. Third phase is also failed, and just we will close 4th phase also. So we know that the only reason is AICTE. We believe that AICTE will sponsor only such an events which are fruitful for each and every faculty and research scholars. Okay. So I thank each and every participant, and I want to convey you that we had sent you the link, and we are getting some messages that it is not accepting responses. So we will open it at just within a minute. So please wait for a minute. The only thing is I want to convey at last. First of all, as per AICTE norms, the attendance must be 80% and the marks must be of 60%. So I believe that everyone will get the certificate. Attempt your exam carefully. So, right. I opened the exam link. You can start writing the exam. The link will be closed by 5 p.m. So please attempt the exam without fail. And from Thursday onwards, we will send you the certificates. Okay. If there is any mistake or any spelling mistake, actually we will design in the same way as we received the details from you. Just now we received a message from Dr. V. Srinivasulu sir, Keshav Memorial College, that the name is something different. So if there are any such issues, you can again fill in the form. We kept that preferred name in the certificate. While you were writing the exam, we had given the second question as preferred name in the certificate. So you clearly mention your name, Doctor, Miss, Mrs., Mr., Professor, whatever it is, whatever the first name, last name is, you please write your details clearly, and the certificates will be from Thursday onwards. I thank all the people who are behind the screen and all the people who are on the screen, the participants. And especially, I believe that this event will be success only if you are able to teach in turn to your students and your colleagues and try to achieve certifications. AWS certifications are there. Try to write them 50% discount will be given for the faculty members directly from AWS. So try to attempt those certifications. And I believe that we will all move forward in the area of cloud. I thank all the trainers and all the faculty members, participants, especially the media people who are going to give a wide publicity, and the guests. Okay. I thank each and everyone. And before leaving, I request only once, if possible, please switch on your videos for a screenshot. Please switch on your videos for a screenshot. So I had also opened, but due to some technical glitch, it was closing automatically. Please switch on your videos. Please switch on your videos. స్క్రీన్షాట్ అయిపోతే చెప్పండి. మీరు థ్యాంక్స్ చెప్పి క్లోజ్ చేసేయండి మేడం. సార్ మీరు కూడా ఆన్ చేయండి వీడియోస్. థ్యాంక్స్ సార్.
Thank you all participants. Now I request the exam link is opening. If it is working, please all of you complete the exam.